So, everybody ready to start? That's becoming quiet. Welcome all to the second edition of the automation event. I'm very proud that we were able to reorganize it and have more attendees than the last one. So apparently we did something good, but we failed a lot last time. Hopefully we will succeed more this time, and you will help us learn for next time. So help us. Afterwards, there will be possibility for feedback. So help us learn, and we'll get there in the end. For now, the automation event today in the news. We're doing good, but there are still concerns. One of the major things that struck me today while reading the news was the last paragraph, which was all about speed. And for me, that's a good thing. I hope Anton will get into that, so I won't go into detail for this. But this is something where the automation event is all focusing at, help us become better and faster. So that's why we're here, and hopefully we'll learn a lot and help each other. Oh, I already said that one. First of all, housekeeping. My name is Sander. I'll be your host for today. That means that the really important people get their hands free to help you guys and make everything run smoothly. If you want to know the agenda or where the workshops are, well, the QR code, you can use it. There's a password, but it's TAS, T-A-S. It's easy. Yeah. There are probably some printouts in the back as well, but I'm not sure. So go there. You have 5 seconds until I change the page. Second one. There's free coffee and tea for now. Just take it, it's in the automatic machines. And during the breaks, there will be snacks and drinks and whatever. So just feel free to take them. If you really don't like it, you can also buy something for yourself, of course, no problem. The building consists of 2 parts. You came in over here with the elevators. This is room 1 to 9. Everything else is in this part. Yeah. So if you go out, go the right way, because last time we learned that people are searching a lot in this building. So, and it takes time. Might result in you missing the first 5 minutes of your workshop or presentation, and we wouldn't want that. So, repeat. This is where we are now. Yeah? Okay. Why focus on learning? I have this kid. The first time I did something about learning and making failures, I put my kid on the back of my bike, and without the seat, yeah, that's, for me, it's this one, yeah? You know you shouldn't be doing that. If he gets his feet in the wheels, like happened with me, I got a formal warning at the hospital. Yeah, they make a note of it. Don't do that 3 times. 3 times you're out. So fortunately, we're a few years further now, but that's not the mistakes we're talking about. Things you learned already or things you should know, yeah, use them. This is the place where we want to be. Experiment, learn, improve, generate new ideas, try them out, fail better next time. That's what we're aiming at. That's why we're talking together here. That's what it's all about. Experiment. Not just trying something you haven't done before. It's about creating a hypothesis that it might improve if you do something different, and then go from there. So we want to know what you learned already. So there's a challenge. If you go out here and to the right, there's these wooden tables. There are 3 laptops over there. And if you go to this URL that you can't read right now, if you subscribed in advance, you already received an email from us. It leads to the same URL. You can subscribe yourself to a free account of Pluralsight, in which there are IQ skills tests. And we thought it would be funny and give us insight, because we want to use facts to improve, to challenge you to show your skills or show where you want to learn some things. Yeah? Just 20 questions, doesn't take that much time, 20 questions. Depending on the answers you give, the questions become easier or more difficult. And in the end, you get an IQ score. It's just a number. There are two people sitting over there, and they would really like to get this number from you. The guy or girl, man or woman, with the highest score, no matter which test you're doing, gets a prize. And eternal fame. We'll be bowing for you and polishing your shoes, whatever you want. But not whatever you want. Whatever we think. That's a dangerous one. Whatever we think is suitable. But show us. I already did the Docker one. I got 102, which is just a little bit more than novice. Well, I'm a manager. I shouldn't be able to know more. So. The agenda. Yeah? Go there. It's fun. The tests are really fun. You've seen the Just Humble movie? I hope you enjoyed it. Buy the book. Yeah. One of the many that he wrote. This is the kickoff. And now we have Anton. We'll do the formal opening of the event. I'm just here to fill the time. And then we have Alan Richardson, who will tell us all about applying automation in software development. Things we want to learn. Yeah. Feel free to ask questions afterwards. I hope you're open for questions. I hope we have time for questions to me as well, but we have coffee and breaks and whatever. Yeah? So, as long as you are there, I hope people will walk to you and don't feel scared. Yeah. So then we have Ellen. Workshops afterwards and presentations. The one you've subscribed to. If you haven't subscribed yet, you could have done. You can do it now if you've made a picture of the QR code. Go to the meetup agenda. And then we have Maarten Dirksen, who will give a presentation about the setting developers free at bol.com. So I hope you have a really good time. Anton, I would like to invite you to the podium and do the formal opening.
Thank you. Where's the ribbon and the scissors to formal openings? Okay, no problem. Thank you. Welcome at the automation event, the sequel, and it's probably not going to be the last one. I'm going to say a little bit about why automation is hugely important and is becoming more and more important to us all here in this room, but to the bank as a whole as well. Second, a little bit about sharing knowledge, because you could also watch this on a video, but you have chosen, and we have chosen, to bring together people in this room. And then about the importance of failure. Well, first of all, the importance of the topic. And I think that you said it very well. It also, Wiebe Draaier mentioned it. Speed is of the utmost importance. It is not so much anymore the idea that the bank that wins is the bank who knows best what is the target architecture or the target operating model and has the best clue about what digital hub should look like. It is about being nimble and being agile and being able to roll with the punches. And speeding up is therefore very important in our software development. Now, I would like to make one thing clear. Speed of development is not just in putting the zeros and the ones behind each other. Another area where we can greatly improve is making sure that we get first time right, what do we exactly want to build? What is the customer preference that we want to tackle? What do we really understand about our business? What do we really understand about the customer needs? Because a lot of time also goes to waste in that part of the process. But if we want to, as an IT organization, and I'm here as director of IT systems standing up on this stage want to speed up, then automation is really crucial. It's a little bit like Darwin said, the ones who survive are the ones who are able to adapt quickest, and not so much the ones that start out with the best starting position. And therefore, automation is important to bring to the table, but it's also important to meet up with each other and to build a network of people that work on this topic. We have set a goal in the managing board of 90% of the teams should be able to bring their code to production in 1 week. Now that's a ludicrous KPI. We're not going to make that KPI probably. But that's not the point. The point is that we're probably now somewhere at 15, 20%, and that we want to make a huge step in the right direction. And we need you to help us figure out which steps that are. And it helps to organize meetings like this, because then you bring the knowledge of many in one room. We hire the best and the brightest in Rabobank. Otherwise, you wouldn't be sitting here, right? Yeah, it's an evidence. This is evidenced by just showing up. But the thing is that what the trap that we fall in is often that we understand that our colleagues are at least as intelligent as we are, but we sometimes fail to share our ideas with them and to listen to their ideas. So every time we're faced with a problem, something in our brain does, okay, got to solve this problem. And you go and sit and try to figure it out together with your team. And maybe the first reflex that you should have is, somebody must have figured this one out. My kids who are 15, 13, and 11 never ask me any questions anymore. They don't try to figure it out themselves either, which is a part of a problem that we are having a discussion over at home. But they go out and search for some answer out there. And I love these kind of get-togethers, these kind of communities, be it the Java community, let's see, wave to Chris Stapper out there, be it the automation network. This is where we can leverage and build upon each other. And we build upon each other not just by showing off what we know, but by being vulnerable in our questions, by saying, I don't know, and by really tapping into the joint knowledge. And that is, talking from personal experience, that is not something we are brought up with. Right? I'm now working for a little bit over 20 years. I look around the room and there are people who have shorter careers and longer careers, but at least when I came out of university, it was not a culture of raising your hand and saying, I don't know. The thing that got you ahead in life and in your career was showing that you could actually do stuff, that you are able to solve problems actually a little bit better than the next guy. And the shift that we're making in our agile way of thinking is no longer believing in the power of the individual, but believing in the power of teams. And we are 400 DevOps teams at Rabobank, but that's not, we're also one team. And we're not just one team at Rabobank, but we're also one team with the IT community in the Netherlands. So, there are some people from bol.com here. Welcome very much. Sharing knowledge, putting things out there, sharing our learnings is something that we should be doing much more frequently. But it doesn't come natural. And one of the things that I had to learn is, well, not in terms of software development, because I totally suck at Java and anything like that programming. I'm an engineer by degree, but you wouldn't have hired me for my programming skills, I can assure you. I did by the way, tried to pick up on Java and Python with Pluralsight during my sabbatical, and decided that being a manager was much more suitable to my strength. So I don't even dare to come close to your IQ tests. They're not for me. So I haven't been programming, and I can't share any failures on that side. But I have been starting programs and being program director. And there was one program that I was adamant about, and it was implementing a global CRM system in wholesale in Rabobank International there. And the business was lukewarm about it, because then you share information, and if as a relationship manager, everybody knows what I know, what will be my value in the company. So there was resistance on that side. But with a couple of other people, I thought, if you want to be a professional organization, a professional sales organization, and you don't have a CRM system, you're just a joke. So we're going to implement this. But if there's resistance, there's passive aggression, and passive aggression with businesses sometimes shows in the form of endless RFCs or requirements that just have no end. And I was pushing and pushing and pushing, and they were pushing back. And it came to a point that the teams were giving signals to me: we're not going to go live on December 1st. And I said, this is a drop-dead deadline. We are going to go live on December 1st. And so they went back and said, okay, we're going live on December 1st. But they went out of the room shaking their heads. This is never going to happen. And finally, on November the 30th, I was at a meeting, and I had to give in. We were not going to go live the day after. And I had been ignoring all kinds of signals, and the result was that on my birthday, a couple of days later, I was at night in a conference call getting slapped by Ralph Dekker and Alex Kloosterman, thinking to myself, when was the CRM idea a good idea anyway in the past? So I went back to the team and I said, sorry, I really didn't listen to you, and we're going to do it differently. And now, yes, it is live, but that thinking, the fact that you cannot push success through somebody's throat, that you have always got to listen to the heartbeat of the team and being open to signals that you might be wrong. Having sessions at the beginning of large programs, why would this be a mistake to start this? These are all things that I took from that experience. And it has made me a lot more effective. So I hope that, and I expect that you have similar stories that you can share with each other, and that we should share with each other, not just to make it salonfähig, as the Germans say, but actually to become a better team. And now I give the floor to Adam. Thank you very much.
Quick test. Oh, you can hear me. That's good. Thank you very much. All right. So whilst the slides are getting over, what it allows me to do is say that in order to tie in with the we made mistakes, what did you learn? What we decided to do deliberately was change the title of the talk. So the talk that you've got on your slides is lessons learned from automating in software development, or automating in software development. That's really a story. When we do agile development, we have goals, then we have stories underneath them. The ultimate goal, really, is to work with agility. So what I really want to do is talk about how to test with agility. That fundamentally is what we're trying to do. And automating fits within that. Everything we do fits within that. So in order to help people speak to me afterwards, I've got stickers. You too could have a sticker like that on your laptop. Very good. I've got multiple stickers. I'm not that scary. You can find me at evotester.com if you want to. Right now, one of the things that we have to learn how to do is have confidence in what we're doing. If I ask you, do you know how to agile? I'm not even sure what that question means. Does that mean how to be agile, how to do agile, how to work in an agile way? Fundamentally, what people are behind pillars. Okay, I might have to move around a little bit. So fundamentally, what we've got is we've got confidence. Can we do this? Do we know what we're trying to do? Can we put this in our head in terms that we understand? Because a lot of the time, what got wrong with me when I was doing this, and I'm going to explain this later on, is we didn't have confidence what we're doing. We didn't understand what we were doing. Because confidence ultimately comes with experience. So if you're trying to do agile, it's new. There's a lot of new terms. There's a lot of new ways of working. We don't necessarily know what we're actually going to do. We don't understand it. So really what we want to do is not work agile, is work with agility, because that's a real word. That's a common sense word. We know what that means in the real world. And the more that we can bring real world experience into what we're doing, the more that we can adapt it in a general way. So what does agility mean? Do you know how multiple ways to perform a task? You've got an outcome you want to achieve. Do you know multiple ways of doing it? If you do, then you understand what you're trying to achieve. You understand subtleties about what you're trying to achieve so that you know how to evaluate different ways of getting there. And you have more experience and you have more confidence in your ability to make decisions and to take responsibility for those decisions. Because fundamentally, when you're working on an agile project or you're trying to build your automated execution, you have to make decisions all the time. And you have to try and make decisions fast when there are decisions that you can backtrack on. Right? Decisions that you can easily move back from, you take quickly. Decisions that you're going to have to commit to and take a long time, you have to try and take a little bit more care and attention before you make them. But we have to learn how to make decisions, unfortunately. We know how to do that in the real world. It's a real world experience that we have. Now, in order for me to try and continue to learn this and keep bringing this in, I try and take lessons from other things that I'm learning. And I think 2 days ago, I was reading Relentless, the Japanese way of marketing. Now, I have no idea whether this is how people do marketing in Japan or not. That's irrelevant to me. I'm looking for other ideas on how to do marketing. But in there's a statement of marketing is fundamentally an application of common sense. And apparently people in Japan prefer synthesizing over analyzing. That means doing stuff rather than just sitting thinking about it. Common words over professional jargon. A lot of the time when I am working with teams and I'm trying to explain testing, I am trying to make everyone communicate in common sense terms, words that everyone understands, because professional terms have a lot of ambiguity. We can implement them in different ways. And we say, are you doing integration testing? Yes, I am doing integration testing. And everyone walks out of the room completely understanding what we're doing, when no one has a clue, because we haven't actually explained it in real words. We've just used terms. The other thing that comes through is simplicity over sophistication. Now, to me, that was the benchmark of Agile when it started. But then when I work with teams, rather than having simple processes, they have built enormously complicated and sophisticated build processes. They're really hard to change. They don't flex very well. Whereas they could have done something simple, which gives you the option to change and flex and work with more agility. But that also is just real world. That's where we start. So as a meta rule, what I'm going to say is that agility trumps agile compliance all the time. It's important to understand your agile context. It's important to understand all the words and all the processes. But agility sitting above that is how you will work. And that's really what I bring in when I work with teams. I help them have the confidence in their real-world experience to help them implement agile, using their experience, their knowledge, their skill sets, and everything they do. Because you have to work with agility. You have to bring in the group mind. You have to bring in all the experience that you've got access to. Fundamentally, marketing is too important to leave to the professionals. Customers will fall through the gaps between specializations. This could just as easily be software development is too important to leave to the professionals. Customers and customer needs will fall through the cracks between specializations. Anyone that's worked on agile teams where you have testers, product owners, programmers will know that stuff falls through the cracks between those specializations. We don't do all the testing in the sprint because the tester's too busy, so we leave it into the next sprint, and we promise we'll do it then. We can't do all the automation in this sprint because the tester's too busy, but we'll do it next sprint and we'll stick it on the backlog. We promise. Stuff falls between the cracks when we focus on specializations and don't work with agility. So we're going to do this with common sense. First of all, in order to understand how to test with agility and to automate with agility, we need to understand testing in common sense words. So what I'm going to encourage you to do is not ask what is testing, not ask why do we test, but instead go what do we get from testing, what do we gain by testing. Instead of looking at the process, because testing is a process, look at the outcome of that process so you can evaluate whether you're getting what you want. So if we were going to do this, what do we achieve by testing? What do we gain from the process of testing? And sometimes you find that out by missing it out. What happens if you don't do it? But you can only evaluate in those terms if you know what the outcome is supposed to be, and if you know how to evaluate the subtleties in the outcome. One of the things that Moshe Feldenkrais, who is a kind of physical therapist, said is, when you know what the outcome is supposed to be, and I'm paraphrasing, this is not what he said. When you know what the outcome is supposed to be, you can spot subtle differences in there, small, subtle distinctions that allow you to vary what you're doing. And that's really what experience gives you. It gives you that subtlety in observation with what you're working with. And the reason I put etc. at the bottom of most of my lists is because you have to deal with them, right? You have to own those lists and add them and expand them and take things off and change them for your environment, because they're not a list. The danger with lists is they look complete. When they're not complete, they're a starting point. They're things that you build on. So what are the outcomes of having tested? Now that's going to vary depending on who you ask. And the good thing here is it focuses our attention on stakeholders, who is involved in this process. Because ultimately we're building a system of development, not just a system that we're building, but a way of building software. So we have stakeholders, they have needs. We might ask some people and they might say that what they gain from testing is confidence. A product owner might gain confidence from having testing. Now, in reality, they already have a belief that the system is going to work. What we really give them is less confidence. Right? We help them understand where it's going wrong. We help them understand what has been covered so that they're not relying on belief anymore, they're relying on evidence. So evidence is one of the things that we get from testing. People might care about bugs because they built something, they think it works, and what they want is feedback that it's not working and how it's not working. There's a whole bunch of things that we get. What this means is when we build a test process, we have to build something that meets these needs. So in common sense terms, if testing was questioning, because testing can be viewed in different ways. Testing can be feedback, testing can be questioning, testing can be whatever other word you put in place. But one way to view testing is questioning. So how do we know that something is working, that a requirement has been built, that the software is doing what it needs? What evidence do we have? What if these things happen? What if we put this data in? What else could someone do with it? These are questions that testing can ask. So in order to answer those questions, we have to have a process, and we might call that process testing. And that process is really, we have to model systems. And if we have a list of acceptance criteria, that's a model of a system. But then we build a model of the system in our head so that we can identify and explore risk. We can figure out what it's going to do. So we have to use appropriate communication when we're explaining that model to other people so we get feedback as to whether our model is correct and whether we're going to approach the right risks and identify the right exploration parts. And then with the actual act of testing, comparing models to systems by experimentation and exploration, that's really testing. That's really what we're doing. We've got a model written down, what we put into our head, that we expand, we figure out what we're going to do, and then we compare that model in our head with what's actually being built. And we do that by exploring, we do that by experimentation. And that, in common sense language, is really a very basic test approach. That's a very high-level generic test approach in common sense terms. So then, to add some agility in there, we have to make it contextual. We have to make it fit in our environment. It has to be flexible. If I worked for a big test consultancy and I came into your project and I said, I have got our test approach and we're going to use it, that is not particularly flexible in approach. And what that's going to lead to is your system is not going to absorb that. Your system is going to isolate that and push it away, and then we'll have a communication link that probably won't work. Because we're building a system of development, and any new system that comes in has to be absorbed into there so that it works effectively. And it has to be responsive to the needs that we have and the timescales and the people. And when I started doing this, I focused on adding value and avoiding waste. That was my big thing. What I did is I looked at the templates that we had for documentation, and I couldn't understand why no one was reading them, because this is what we had to do. We were mandated to use these templates. So I looked at what was adding value in it to the customers by looking at what they wanted to learn. And I used those parts. I looked at what was adding value to me as a tester in order to think about my process. And everything that I thought was waste and didn't add value to the customer moved to the back. But unfortunately, it still added value for the people that had process compliance in mind, because they were stakeholders of this document that we're producing. So that's a lean principle thing. That's one of the lean manufacturing things. Focus on value and avoid waste. And we have to decide what that is by understanding what people need out of our process and our communication and what we're trying to do. And very often, the people who do testing are the people who have to say the right thing even when no one wants to hear it. They have to do the right thing even when no one wants to see people do it. That's why I picked the evil tester thing. We have to be prepared to do things that other people will not do, that other people are not even conceptualizing that we could do, but it's the right thing to do, even if the general conception on the project is that it's not the right thing. And I know that agility trumps agile compliance because I had to learn to be agile on non-agile projects. And the good thing is that then should have helped me when I joined agile projects, but it didn't because I forgot. But agile projects force us to work with more agility. We can't get away with what used to happen in testing because hopefully we've got reduced documentation. People don't spend as much time on documentation. It's not always true because you start a project and someone's created a huge backlog, which is really detailed. Then you start prioritizing it. But hopefully we've got less upfront information. Because we've got smaller time scales, we have to work better and faster and tighter. And hopefully we're co-located, we're working. I mean, I've worked on agile projects that were not co-located. That was useful, having to run across the road to speak to people. Where we weren't testing and developing in parallel. People still outsource testing. People still outsource automating even when they're doing agile, because there's not really agility in their process. And that's really what we're trying to build. So we have some constraints when we start calling our project as agile that should lead to that. And then we have agile rituals and definitions. So we have to understand these because this is the context we work in. So we've got Three Amigos, startups, retrospectives, story points, stories, whatever else. And we've got a lot of terminology in there. Now, we have to understand what they actually mean, what they are for. It's not just about going through the ritual of Three Amigos where three people go off in a corner and have a chat. We have to know what is expected from that. Are they expected to write down their requirements? Are they expected to write down decisions? Are they expected to communicate the decisions to other people so that we're not having a meeting with 12 people, we've actually managed to achieve it with 3? What is the outcome of that so that we know what the expectations of these processes are? Otherwise, we might just go through the rituals and comply with them. And from a testing perspective, we have the problem that there's not really a lot about testing in there. It looks like there might be. Right, we've got acceptance test-driven development, software development engineers in test. We've got a definition of done that probably mentions testing. Right, we are not done until we have tested. We have not done until we have completed our test automation, and that's it. That's what it says. So we can interpret that in however many ways we want. But really, these things are not really testing. Test-driven development is a design methodology. It's a way of constructing code by writing code. BDD is a way of having communication, and effective communication. Now, if you extend these, what you get is some of the outcomes that we've normally associated with testing are side effects of this. TDD, side effect of TDD is that you have code that automatically executes other code and asserts on it, which looks very much like a testing process, but that's a side effect of having gone through the TDD process. BDD, very often people conflate that with testing because you're coming up with acceptance criteria, which you write in a natural language, which comes through Gherkin, which you might find a Gherkin tool, which you then might automate, which then executes an application and asserts on it, which gives you some of the gains that we've associated with testing. Right? Because some of the outcomes of these processes overlap with the outcomes that we've had from testing, but that doesn't necessarily make them testing. So we have to figure out what testing actually means. But what it does not mean is that we don't need to test because we are doing TDD. We don't need to do any testing because we have got BDD, right? It just means that testing is no longer the only way to achieve those gains. We brought in new ways of working in our system that allow us to then test differently. We've automated, we've made easier some of the most basic parts of testing. So then we have to look at, well, how does testing actually fit into Agile? And part of the problem with Agile is that Agile is hard when we try to be Agile. So what we have to do is we have to work flexibly, communicate effectively with common sense, and fundamentally trust in ourselves as individuals and as teams to do the work so that we can work together. We don't just be Agile. Now, the reason I stress this is because I did a lot of work on projects before moving into my first Agile project, and I had focused on value and avoided waste and done a whole bunch of stuff to make myself really effective. And I worked very differently than other people. But when I started in an Agile project, it's my first Agile project, I joined it because I wanted to learn Agile, because that was going to be the way forward. And I'd read the books, I'd done a lot of analysis, I just hadn't done the work. So when I joined the team, I'm the only tester, we've got 4 developers. And the 4 developers have been working with the people that want the actual requirements, working very close to them. They've been delivering stuff out there, the stuff's gone out, it's kind of worked, kind of not. They found bugs later on, we couldn't respond to them effectively. They discovered that what was delivered was not really what they needed. So how do you fix problems like that? You've got bugs, you've got requirements that are not really being addressed, we'll test it. So you bring in a tester. So the management team brought in a tester, which is me, for the Agile project. But because I didn't really know what I was doing, I was relying on these Agile experts to help us, but because the Agile definitions don't really have testing in them, they didn't really know how to absorb a tester into their process. So we tried things that we thought we were supposed to do, like pairing on code. So I sat down, we started to pair on TDD, but my development skills at that point were not good enough. It taught me that my development skills had to improve in order to pair with developers. But what we eventually figured out was there was more value in using my technical skills as part of the review process from TDD. So not actually pairing on the TDD, but reviewing the test afterwards, reviewing the test coverage, doing some experimentation and exploration in those tests. So at the unit test level, changing the data, see if it gave us any more information, see if the things that we experimented with changed the model in the tests that were in there. That was using the skill sets in that environment, not trying to fit in with the rituals, but figure out where we could add most value. And that happened throughout the process in terms of I was asking more questions in the grooming sessions with the stories to make sure the acceptance criteria were not as ambiguous, because testers very often can focus in and identify ambiguity and raise those questions more than other people. Nowadays, Agile is very often the only way of working that some people see. So they come out of university or they come out of training and they're on an Agile project. And every Agile project is different. So they're in the stand-up and they're in the retrospective and they go, well, this is not Agile. What are you doing? This is not what I learned Agile was. And then they'll say that. But they don't have the flexibility to know how to change it. They think that compliance with the rituals is the thing to do. And very often when we don't know what to do, what we do is we do comply with the rituals. And then we think, well, if we do all these rituals, we'll be okay. But we don't know what the outcome is supposed to be. And then when pressure comes in and we start getting squeezed for time, we don't know how to adapt those rituals. So we drop the retrospective, or we drop the stand-up a couple of times, or we don't have enough discussions earlier on, because we don't know what they're really supposed to achieve. And then we don't know which bits to miss out. And then we start getting in a bit of a mess. So then we have to wait for the coach, because the coach will convince us and tell us what we have to do. But sometimes the coach is only trained in Agile rituals and not in the flexibility required for software development. But really, what we need to learn how to do is harness our own individuality, working as a team, our own agility in order to make these things work. Because if we had worked with agility to try and figure out different ways of doing things, knowing what the outcome was, the Agile rituals then can just support us in doing that, and we can tailor them and customize them for what we want to do. Sticking to the actual rituals as we understood them, which was not very well, led to rigidity, forced us not to experiment because we thought we were doing the right thing, rather than bringing in the agility we wanted. And I think the key to this for me is focusing on outcomes rather than the actual process that we believe will implement them. We do have to get the processes right, but we first of all have to get our outcomes right. So in that sense, what is agile software development? If we're going to do agile, what really is agile software development? And for me, it's regular releasing software that works and which adds value with each release. Now that's a bit ambiguous. What does works mean? What does add value mean? How often do we have to release it? But fundamentally, that's what I think we're trying to do. We're trying to release software to someone so that they can use it and add value. So given that, how do we then test with agility? Well, how do we know that we're regularly releasing software that works and adds value with each release? Or how do we know it works? What does works mean? Does it mean that it's doing what it should? Does it mean that it's not doing what it shouldn't? How do we know that it's actually adding value? Now, fortunately, some of the agile practices that we've seen earlier, like BDD, answer some of these questions. If we define works to mean complies with the acceptance criteria, then BDD can help us with that. But it doesn't necessarily answer, does it do what it shouldn't? Right? Because testing will do that. But then we can see the limits and the overlap of what are our existing processes, what else do we need to do to figure out what can testing add? So we can test fundamentally to add those questions. And in the past, we tested to say things like, how do we know it works? How do we know it complies with the requirements? That's what testing did. It never had time to figure out, how do we know it doesn't do what it shouldn't? Because we were too busy over there. Now we've got other things that can help us. So what we're trying to do is when we have an agile process is we augment it with testing. We don't have a testing process that sits alongside it. Testing is part of that agile process. Testing is part of that system of development. We automate as part of that system of development. So at a high level to understand it, we've got goals, which are very high level statements of what we want. We split those down into stories, which are better statements. We write acceptance criteria. We actually start doing development work. So on a common sense level, what does testing mean within that? So at the goals and high level, you can ask questions. You can identify risks. You can say, what if we do this before this one? What is the technology risk? How long is this likely to take? What does this require? When it comes down to stories, things get more detailed. So you can actually start making notes on how you're going to test it. What does it mean that this works, even before you've written the acceptance criteria? When you get the acceptance criteria, you can do the same thing. You can actually start saying, this is what we will actually cover, and this is what we will not cover. And that's really important when you get to do exploratory testing, because exploratory testing can go off and cover loads of things unless you rein it in. How do you know when to stop? Because we've decided roughly what we might want to cover and what we will not. Then when we get into the actual development work of doing this, we've got to validate those acceptance criteria. We might want to automate the acceptance criteria validation so that we can use it in continuous integration, so that we continually assert whether the acceptance criteria still works. We might want to then do exploratory testing based on all the questions, all the risks, all the models. What we learned from automating the acceptance criteria, what we learned from checking whether the acceptance criteria had been met. Because that's a learning process, that exploratory testing process. You expand your model as you do it. All the other ones validate the model. Exploratory testing expands your model so that you can do more. Now then we come down to the question of, well, who's going to do all this testing? Because we've got 6 developers in the team and 1 tester. Who's going to do all this? But that's because we've still got this conception of testing. As all these testing things, we've ignored the overlap with all the other processes that we've got. Fundamentally, anyone can ask questions. Anyone can identify risks. Anyone can make notes, particularly when it comes to acceptance criteria validation. If you've written down your acceptance criteria and your acceptance criteria has examples, why does a tester have to check that those examples work? Right? Anyone can do that. It's pretty obvious how you do it. In fact, if you get your business owners doing it, they will add a different set of value because they will observe different things as they do it. The reason we're able to automate it is pretty much because anyone could do it. But people with testing skills will do it differently. The whole point here is testing approaches this differently, observes things differently. But we need to harness everyone on the team. So when it comes to automating the acceptance criteria, what some people call test automation, it isn't really test automation. If we give it that banner, that's fine. But in common sense terms, it's automating the acceptance criteria so we can put it under continuous integration. Now, we need clearly people who can code to do that. But if we have people who have testing skills in there and helping with that, the way that we automate it doesn't just support the automated validation of acceptance criteria, we can also use that automated code to support our testing, because we're looking at building something that has more variety in it, that allows us to do more things. Very often when I'm working with teams, and they'll be using BDD, so they've got everything in Gherkin. So then they automate with everything at high level, Gherkin level, then everything maps on its steps. Then when you try to use any of that automated code for exploratory testing, you can't, because you have to write it in Gherkin. You can't just stick it into a JUnit test and wrap it and load in some data and randomly do some data, or convert it into a model-based test using your existing abstractions. You can't, because you haven't built it in that way. You haven't built it with the variety that if you'd viewed it from a testing perspective, it would have. Because what you've done is you've automated the acceptance criteria validation. Which is a perfectly fine goal, but you might want to extend it. And then when it comes to exploratory testing, typically that's where you want people who can test. Because what they've learned how to do is build models and expand models as on the fly as they're executing systems to come up with more ideas, more risks, more data, more questions. And very often when you then want to do technical evaluation of it, so looking at the actual implementation, because the acceptance criteria doesn't really tell you what the implementation is going to be. It doesn't tell you that you're going to use a microservice using this technology, passing these messages, and this is the message format. So you have to look at the actual implementation and expand your model to know whether there's any new risks in there, whether there's any more questions you should be asking at that point. That's where exploratory testing comes in. Now, when business users do exploratory testing, what they notice, because they can observe in more subtle details the business and the data and how that works. So they will spot things that other people miss at that level. Testers can spot more things at a different level. Because what we're trying to do when we work with agility is utilizing all the skills. Very often, people feel hemmed in on agile projects because they're testers. They already know how to code a bit, but they're only allowed to use their testing skills. So then we created the software development engineer and test role, but then we want them to do more software development than testing. So we brought developers into that, and developers don't know the testing part. And we're focused on roles, and what we want are skills, and we still need people who can test well. Because someone who can test well will see opportunities to test that other people do not see at a high level, a generic level. And this applies to every role. Someone who can code well will see opportunities to code that other people do not see. And that's why we have dependency management systems, and build systems, and continuous integration systems. Because people who can code saw opportunities for making that work better. People who can test see opportunities to test that other people do not see. They see risks that people do not see when they are using those models. And hopefully, the value that a tester adds on projects is that they can test better than other people. If the tester cannot test better than other people, you should possibly question why they're on your team, or help them improve so they can test better. That's their part in that team. They have the testing skills to augment the team. It doesn't mean that they do the testing. They can work with people to test better. And it's really important, particularly in agile projects, that we actually give people the time to apply their skills. Because very often we get hung up on them. We have committed to doing these stories, we must do these stories, but they expand as we look at them. Testing in particular helps you expand what is going on. So if we don't give people enough time, we don't adapt what we're doing, it very often doesn't work. So when it comes to automating stuff, people very often get hung up on automated testing. So we'll ask questions like, well, should we automate? How much should we automate? Should we automate through the GUI? Automate through the GUI is flaky. We shouldn't do that. We should have an API. We don't have an API. How are we going to automate under the GUI if we don't have an API? What are we going to do? When do we do this? Who's going to do it? These are all process questions. These are all how do we do this stuff? And people get hung up there. They get hung up on what tool should we use, when should we do it. The reality is what we should be doing is figuring out what questions do we want our automated testing to answer. Not why are we automating? I really want to distinguish this. A lot of people say, well, we should ask why. And that's great. Why should we do automated testing? Because we're doing Agile. And that's what we do in Agile. Why should we do automated testing? Because we want to put it in the CI. That's a why answer. It's a belief question. It's a high-level belief question. Okay, so what do we want our automated testing to answer for us? Because we are Agile. Right? It's not the same thing. It's not the same belief set. We have to understand what we're trying to achieve. We have to focus on the outcome. We have to be clear what the outcome is. If we want our automated testing to answer the question, does this software work? We have to know what work means. Does this software continue to meet the agreed acceptance criteria? Okay, that we could do that. We could answer that. We could automate the acceptance criteria and see if it continues to work. That could be our goal for automating. We want to use the abstraction layers that we create to support our exploratory testing to allow us to expand the scope of data that we cover when we do exploratory testing. Okay, we could do that. We could build our automated abstraction layers in a different way to support that and still check that the acceptance criteria continues to work. Those are not why question answers. Those are what do we want this to achieve. Those are outcome question answers. And if we know what the outcome is and we care about it, then we give people the time to do it and we commit to doing it. If it's why are we doing this because we are agile, then we don't care. We don't care enough to drop stories out because we're not going to actually finish them in the sprint. If we know what the outcome is, that we don't trust a story being finished until we have automated the acceptance criteria and seen it pass in continuous integration. What question does our continuous integration answer? Well, every time we check something in, all the executed assertions that we've got pass so that we know it continues to work. Very often that's not the outcome of continuous integration. Very often the outcome of continuous integration is we have continuous integration. Therefore, we check code in. When it doesn't pass all its automated assertions, well, maybe it will next time, right? Because the outcome is not clear in our heads and we're not working towards it and we don't put the time in to make it work. Now, when we are doing automated execution, it's clearly a multi-skilled activity because you're working from a testing perspective and you're working from a development perspective. And you want to have good code in there because it is going to last as long as your actual system, if not longer. Sometimes we change the system underneath the automated execution, but keep the automated execution going in parallel. Sometimes we'll build a new system to replace the old one, but we want the automated execution to work on both because then we know whether the new system works. So it has to be good. We have to commit. And you are missing a trick, I guarantee, if you're only using the automated execution to validate your assertion criteria. If you're not using it to support your exploration, you're not using the work that you've done as effectively. You could be having bots that are crawling your system, using the exact same abstractions, using the same synchronization, robustly exploring your application in parallel to what you're doing. But we also have to be aware that sometimes it just isn't worth the effort. I've worked on agile projects. We were working on new websites, and very often it was CMS driven, but we were agile. So because we were agile, we automated. So we had to figure out how to automate this. We had to make the automation quite sophisticated because it had lots of variable data coming in from a CMS system that it was still working through. But sometimes it isn't worth the effort because essentially all that automated execution was throwaway after the system was released. But if we'd known as an outcome, what is the outcome for this, we might not have done that. But we know that acceptance criteria isn't enough because it doesn't really define how you're actually going to implement it. And it doesn't also tell you what is the risk and impact on other parts of the system. When we're looking at acceptance criteria, we have to look at the implementation. And the acceptance criteria doesn't tell us how deep we have to go. It doesn't tell us that we need to look at the HTTP traffic to see what else it is exposing. If we're not observing at those levels, we might not notice that we're actually using AJAX image caching, but it's not working, and we're downloading the image twice, which is really bad on mobile because we've just massively increased the load because we're trying to do something clever. But we didn't notice because we didn't explore at that technical level. Because exploratory testing and technical testing are there for asking the what-if questions and what else, and that requires us to observe, and it requires us to use new tools to expand to different levels and expand our models. Because we're using the results of that exploration to expand and improve our testing, which we very often don't do when we're automating. For some reason, people get hung up on, well, should we still do end-to-end testing because we're doing Agile? Should we? And the answer is really, well, it's not really to do with Agile. It's to do with have you architected your system such that you do not need to? Have you removed the risk that you need to check for in end-to-end testing? If you're doing microservices, that's great, but have you actually versioned contracts? Have you actually made sure that the interface between them works? Are they really isolated, or is data flowing through them into another service, in which case you might care? Are you using something like Pact and then automatically updating the interfaces, but you're allowing that to happen whenever, and anyone can change it and it's uncontrolled? Unless you're architecting your system to remove risk, you probably need to test for risk. The reason we need agility is that everything that we do on Agile is completely customized and tailored. Every Agile project works differently. Every Agile project has different skills in it, different people, there's different requirements, there's different technology. We need to tailor this for the organization and environment that we're at. Because fundamentally, we're building a system of development. Building a system under development, system under test, we're building a system of development. We want that system to work effectively in our environment, to meet the stakeholder needs, the management needs, to handle the staff we've got, the technology we're using, all of this, because people are fundamentally part of that system, and people will automate. That's what we do. We invented the wheel, we automate. We do this naturally because we're trying to remove drudgery and we're trying to check things fast. And we will also test as part of that system because we need to know which signals are important, which signals should we ignore, which signals should we pay attention to. Testing helps give you that information. Now, because I like to bring in external information to help me and expand my knowledge that I can apply, I've gained a lot from cybernetics. Cybernetics started up in the 1940s. A bunch of people, biologists, physicists, engineers, psychologists, people trying to get together, everyone that had worked in systems to share their knowledge, to see if there's commonalities, to then help them build the new generation of guided missiles. That's why we came on cybernetics. But what they're looking in there is feedback. Science of feedback and control is really important in there. But what I took from it is requisite variety. Do we have the skill sets, the knowledge to allow us to exist in our environment? If you're an organism and you can only handle a variation in temperature this big, but the temperature varies to this, you die. Right? We can't afford that to happen. So our teams need to have requisite variety and our processes need to flex. Moshe Feldenkrais was a physicist who also did judo, who then moved into doing physical therapy that was kind of psychotherapy. What he said was learning means at least having another way of doing the same thing. But to do that, you need to know what the outcome is. You need to know how to evaluate that outcome. And he was very big on experimentation, trying something different to see if it works. Not necessarily paying attention to the gurus, not paying attention to the people that are telling you what you have to do, but taking some time. Because if you can make a decision that you can backtrack from, you can make that decision fast. If you can make a decision that you have to commit to for a long time, you better take your time to see if it works. Now, this is going back to where we started in terms of confidence. So you have to figure out, can you trust yourself first? Are you confident in yourself? Are you over-reliant on everyone else? Do you have the skill sets you need? Do you have the technical skill sets? Do you understand the technology? Do you have the skills to say, this is a problem? We need to work on this, or not. Because it's not just working as a team, right? We have to have the necessary skills and attitudes. So we start with ourselves, then we can look at the team. Because we have to trust the team. We have to work together as a team. Figure out, are we as a team trustworthy? Are we doing the things we're supposed to do? Do we have the checks and balances in such that we can adjust? And are we experienced and flexible? Because fundamentally, working on Agile is hard when we try to be agile. What we want to do is understand what outcomes we're trying to achieve, figure out how to work flexibly, communicate in common sense, think in common sense terms so that we know whether we're doing it right, and trust in yourselves and your team. Because only then can you ever fundamentally work with agility. Thank you very much.
Thank you.
Do we have time for questions?
There is no time for questions, unfortunately, but there is time to go to the workshops and the presentations at this moment.
So grab me afterwards for questions and get stickers.
You'll be here?
I'll be here all day.
All day? Okay, that's good. Grab him where you can. Thank you. Have fun today.
Deze stoppen nu of zo? Niet,
Dat weet ik niet. Zoals zij...
Gaan we even kijken wat de bedoeling is.
Ik moet normaal in deze ruimte blijven.
Jij moet hier blijven? Hij heeft hem nog gewoon nodig nu. Prima hoor.
Ja.
Gestreamd.
Ja, alleen deze zou wat gestreamd.
Ja, volgens mij moet ik ook blijven.
We hebben andere mensen op deze scherm. Niet in YouTube.
Geen idee. Het is even erg rustig.
Ja, toch?
Ja.
Het is echt niemand kijkt. Maar ik weet niet wat het interessant is. Kan je bek confusie.
Stond het hier ergens op of zo dan? Of,
Ik weet niet, hij zei iets met...
Hoe weten mensen dan dat ze mee kunnen kijken? Confluence?
Ja, hij wou toch met je naar Confluence. Dus ik weet niet wat ze zo gaat. Oh, heeft hij gesproken?
Ja, er is een Amerikaan die komt. Alan Richardson is een bekende. Oh ja. Een bekende testguru.
Maar hij is dus niet bij elkaar.
Nee. Ja.
Gewoon van buiten.
Ja, precies.
Oké.
Maar ik kom wel iets strak verhaal of zo. Voor de laatste bij de horen. Maar goed, nou even. Volgens mij moet ik je ook blijven doen.
Ja, heb je ook.
Dat is Lounge 13, is dat hè? Ja, dat is hier.
Ja, dat zie ik. Oh, die zit er
Dus
hier.
ja, blijf er dus. Even wat drinken pakken.
Yes.
It's not being recorded as well as streaming. It's not being recorded as well as live streaming.
Well, it is live stream.
Yeah, online.
Yeah.
All right, great. So I'll be with the YouTube. Yeah, right. So Rabobank. I will send a link to Twitch.
I'll take your phone here. I was like, oh, maybe you're timing yourself.
So I can time myself. I was timing myself.
You actually small. Throw it at anyone with a push.
And then they will turn it off?
Yeah, I think you just.
So if I time it now, it will.
En hier gaat. Yes.
Ook om zeker.
Ja. Klopt, Duitsland. Ja, en vanuit
Yeah. But I was like, do you know yourself or should I? Oh, you started earlier. Right, a little bit. Yeah, because it was 10 past 1 or something. Ah. I was like, will you see it? You know, like, how can I get your attention if you don't see it?
Yeah, I think you would manage on yourself.
Yeah. Yeah, because it's low. So I left it 20 minutes more.
Yeah. Okay. Weet je wat is vanaf de pauze of zo? Of is het meteen beginnen? Ja, oké. Ja. Nou, ik denk dat ik een keer aan het tijd komen, dus dat is heel Ik ben de volgende spreker. Hoi. Dankjewel. Dat is de tijd.
Nog wel meer doen?
Nee,
We hebben 20, 10.
ja, nou, ik moet heel eerlijk zeggen, ik denk niet dat ik aan de tijd kom. Dus verwacht ik.
Oké, dus. Nou,
10 minuten. Is goed.
Fris ineens hier.
ja, ze hebben vragen.
Oh, heel fris.
Moeten we eigenlijk bijna weer doen? Wat is straks weer doen? Dus ineens van hoef.
Wat fel, hè? Nou.
Ja.
Ik weet niet of het... Zullen we maar gewoon beginnen?
Dat is nog vrij rustig. Dus, nou.
Ja. Ik weet niet hoe we met de tijd zitten.
Ja, ik hoop dat het begint.
Ja, dat is wel...
Ja, 10 over.
10 over nu? Nog 2 minuten.
Officieel.
Ja, daarom dacht ik.
Just quickly wait for everybody to get a coffee or a drink, and then I'll kick off. Good to go. Right, welcome everybody. Nope. Go there. Some startup. Learn for next time how to operate. My name is Ted van Halen. I'm a software engineer. I work in WRR risk data. In my current role, focusing on automating the build and deployment process. The project I'm working on is a data warehouse project, liquidity risk, credit risk data warehouse, mainly on the Microsoft stack, so SQL Server. We do some website, small websites, .NET, C#. And why is it that one? Let me get the correct button. So today I want to talk you through a journey we've taken over the last few months, moving from Excel deploy towards using TFS Release as our deployment tool. We have an ID, we have a dot on the horizon, a goal that we want to achieve with all our deployment and build processes where we work. And obviously we have an idea how to get there. There's a small road we can see, but as you probably all know, it's quite difficult to look around the corner. And after each corner there can be another challenge. After each hill you don't know what's coming. You see the goal in the end on the horizon, the dot, but still things could turn out really different from what you expect. So to tell you what we went through with RDW, I just want to explain a bit where we started from. Most of you probably know this kind of deployment. We started out with using scripts, using runbooks, big runbooks where each step was detailed, handing them over to a DBA or Windows engineer, and in the end we would probably just sit next to them and fix everything on the spot because it didn't work. There were differences in infrastructure, differences in policy settings, all these kind of things.
So that was really what we started off with. Obviously, no one wanted to support this because everybody after a while knew, well, this is going wrong, and you do it this time. And it was just a big hassle to get everything released to production. And then I think it was around 2014, XL Deploy came around. It was used by another team. I had a look at it and I thought, well, that might be a good opportunity for us to actually sort of get some structure in our release and deployment process. So I started off basically trying this for a web application, and that actually worked out fine, and it helped us in a lot of ways. So when we saw this, we thought, well, we can do this also for all the other parts of the credit risk data warehouse at that point. So what we went off with, we looked at all the steps we had to take, we looked closely at our runbook, and we just started automating everything and making it as robust as possible. So we could do this using the tool, do it repeatedly, and get some confidence in what we were doing. The tool also allowed for configuration management, which was really great, because up to then we would just have like XML files, which were obviously difficult to edit, easy to make mistakes there. So that was another benefit. And we gained a lot of confidence using this tool in our deployment process. We could do it repeatedly, and we could also show the business that we could, because the business also lacked confidence in our deployment process, which ultimately led to long release cycles, because everybody was afraid, well, if we release, we spend a lot of time fixing everything, so don't release too often. We had quarterly releases, releasing big chunks of changes, which obviously increases the risk anyway. And using XL Deploy, we managed to remove a lot of that risk. So we got more confidence, our business got more confidence, and we managed to go to another release schedule, like a monthly schedule. And we could even improve on that. We stuck to the monthly release schedule because the whole business process is also a monthly process, and they'd rather not have us interfere with the monthly process. So we had a small time window where we could release, and we stuck to that. But with the increasing confidence, we could also deliver fixes during the monthly processes, even release a bit more often. So time to market would also improve very much. And it really, really helped us a lot. Also, the way we saw our deployment process, think about these things, improve on it. But then it's still something went wrong. I think maybe it's because of the popularity of XL Deploy, loads of teams using it. And I think like spring of last year, summer of last year, we had a lot of problems with the availability of XL Deploy. I would come in early in the morning in the office, and I would see that our nightly build had stopped for some reason. And for us, that was really a big deal. Our project has a long-running regression and integration test, which we would run overnight. And they started failing really regularly, which was, for us, it was, basically a deal breaker. We could not have them failing, because it would be a day wasted, a day without feedback, and rerunning them during the day was almost not possible, because we had tests running from 5 to 10 hours, like test sets with thousands of tests, and it's just not, it doesn't really help if you come in the morning, you restart your test or your deployment at 8 or 9 in the morning, and you have to wait until 6 or 7 in the evening to get any results. So what we did is, generally we were very happy with XL Deploy. So we thought, well, we have a big team, we have resources, we have the skills, why not get our own instance of XL Deploy? Which was a good idea. We believed in it, we thought, well, we can do that. So we went about, got a server, and went to set up our own instance. And that has really also brought us a lot of good stuff, because we could also immediately improve some things which we didn't like that much about XL Deploy or the centralized version. So what we found, we had some good stuff. We got an instance and we put it in Toulon. I'm not sure if you're all familiar with the infrastructure, where we have an instance in development LAN and an instance in production LAN. And there's some gateway in between which moves packages from one instance to the next. We thought, well, let's put it in Toulon. We have one instance, we can do everything across all domains, and we can track the whole package from DevLAN to UAT to ProdLAN. And that worked out really well for us. Another thing we could do, since we had control over the machine ourselves, we could stick to the latest version. We could just get like the latest version that was released, and we could just easily deploy that, no problem. Didn't take too much time, and we could just go ahead, no worries about our teams. And of course, since we were the only user, it had some real performance benefits as well, especially using the UI in there. But running this for a while, we figured something else out, which was the bad part of this. Operations. There's actually a bit more to running this kind of software than just installing it on a server and then think, well, that will work. We're basically operating it with 3 people, but we're not there 24/7. You have user maintenance, you have other maintenance issues. Upgrading the system and just keeping it running, and I think we did really underestimate all the work involved in this. We just thought spin up a server and let it go, and that's fine. But it wasn't. And then, of course, there's also the ugly bit, which we didn't anticipate. There were more problems. We had a few, with the newer versions, there were some problems running the software. We would get deployments that would just stop halfway through. We had a very hard time figuring out why. We communicated with the vendor, but we didn't really feel that we got the proper response. We didn't really felt confident about what they were doing for us. And at some point, probably after installing a new version, these errors disappeared again. And we still don't know if they did anything about it or not, or if it's something to do within our environment. But there's other problems again. Nowadays we regularly see that the service is just stopping for we don't know what reason. So we're not really confident about XL Deploy anymore. Communication with the vendor has done a lot in that area. And I think that was the point where we said, well, maybe we should look a bit further, look to something else that we can use. So we were basically at a crossroads, either go with XL Deploy and assure that these problems get fixed, or we go and look and explore another direction. And really, we really lacked the confidence to go ahead and use XL Deploy. So we said, well, let's have a look around and explore some other options. And the option we found, we actually decided rather quickly on going that way. We briefly considered using Octopus Deploy, but weren't that confident. We had some knowledge about that, but not really widespread. There were other things about Octopus Deploy that we didn't particularly like, so we thought, well, let's go for the other option. We have got TFS release. Why not try that? It's changed over time, so why not go and try that? And why? We already have it. It's part of TFS. It's already there. We don't need to go and talk to other vendors, whatever. It's just there. We can just use it. No extra cost. Great. Another thing we really like about TFS, which appealed to us, we have our source code. It's all in TFS. So TFS is already a source repository. We have our backlogs in TFS, so all our work items are in there, tracing changes, tracing what we're doing is already in there. Our build process is run using TFS. So if we can also use the release and deployment tooling, we can basically follow every change from going into the, being checked in into your repository and moving it all the way from development to UAT to pod to production. And we can track and trace it, which is, we thought is a really big benefit. So we have one tool to basically rule the whole process. Another thing we really liked about TFS is that it has a proven track record of availability. I think I was there when it was first set up, Twan van Dong. And I think since then, it has a really amazing track record of being online. I can hardly remember any time that it wasn't available, maybe except for some network issues. But apart from that, it's great, and that's what we're after. We're after availability. When we started using XL Deploy and we got a robust, repeatable deployment process, we just raised the bar. We have that process now, but we want to have it always. It needs to be always on. And that's another appealing aspect of using TFS. We had knowledge in our team about TFS, like in-depth knowledge, but also enough knowledge to work with it. TFS is also easy to customize. You can build your own, create your own extensions or customizations. A release works with build tasks, and there are templates for build tasks. So basically a JSON file which gives you control over your UI. Then there's a PowerShell script that offers you a hook, and then you can start doing anything you like. Often said there's no such thing as a silver bullet, but when it comes to Windows, I think with PowerShell you have something that gets really close to it. So, and that's another thing we really like. It's easy for us to customize and to adjust to our needs, and we don't need to go through complicated infrastructure or change processes to have this done. And then obviously with TFS being a Microsoft product, there's a huge community using these tools. And what we've also noticed specifically with TFS release, there's a lot of momentum going on improving on these kind of tools, which we like very much. One of the drawbacks maybe is that there's the changes go so fast that documentation hardly keeps up with it. So if you want to try the real new stuff, it's very, very difficult sometimes to find good examples, and you really have to pioneer or explore it yourself in a way. So TFS release then, what does it offer us? It offers us conceptually more or less the same as XL Deploy. TFS release uses release definitions, which basically are your recipe for deploying your software. Not only your recipe, but it also includes your ingredients, being the artifacts that you produce from your build. And in that sense, it's very difficult or very similar to the Dart package we use in XL Deploy, where you have your manifest in there and all your deployables. So conceptually, it's not really different. It also offers configuration management, TFS release. You can put in all kinds of variables, which you can then apply when moving from one environment to the next. So you can have environment-specific configuration, and you can also have configuration that's more or less crossing environments, but I'll show you that in a bit. And then the other thing that's specific to using TFS release are the agents. It's really pretty much the same as running a build. You have an agent somewhere on a server that executes your build tasks, and for release management you have an agent on a server which executes your release tasks. What you need to set up, obviously, and that's similar to using Excel deploy, the target infrastructure you want to release to needs to be accessible by your agent. So in Excel deploy, you can provide credentials with which you can get to a particular part of your infrastructure. And here you need to make sure that your agents can access your targets. This is basically an example of how we set up TFS release for CDW right now. And it clearly shows you the whole pipeline. And on the left, you can see a few things which are the artifacts that are actually used for the pipeline. So we set up a very simple release pipeline which goes from a dev environment, where you can run your integration and regression test, which can then be moved on to a UAT environment, then to a pod environment, to finally end up in a pod environment. What you can do in TFS release is, when moving from one environment to the next, you can configure all kinds of triggers, how you want to move it. You can just say, well, if my dev environment succeeds, just go ahead and install it on UAT. If you don't like that, you can also say, well, I want to do it manually, or I need approval first from someone, and then it can all be configured, it can all be orchestrated on how you want to do that. Another part of the release definition are the list of tasks. Now, this is a screenshot of a number of tasks we use to deploy our software. So your release definition is your recipe. It contains your ingredients, your artifacts. It also contains the environments that you can target with this specific release definition. And these are the tasks it needs to execute. So on the left hand, you can see the order of tasks. They're just from the top, they will be executed from the top down. And on the right hand side, you can see for each task how to configure them. And you might, if you notice, there are some configuration items in here which start with a $sign and parentheses. These refer to variables in your configuration. So that's how you can use these variables. You can just put them in here. And then this recipe work for each environment with its own set of configuration items. And then here is the variables tab, is where we basically store all the configuration items. The long list. On the right hand side, you can see the scope. No, I'm not sure it's very easy to read, but basically the scope can be either an environment or a complete release. So a variable can relate to one particular environment, or it can relate to the whole release. And there's a few other tabs behind it, like retention policy. I think that speaks for itself. You can have different settings on your retention, on how you want to retain your releases. In the options tab, you can, for example, specify your release name, how it's like a naming convention for your release. And what's also very handy is the history. Creating these release definitions, they're obviously immediately stored in TFS, and the history gives you an audit trail of all the changes to your release definition. So if someone wants to change something in your recipe, then it's always auditable. You can track and trace this, which I think is a really good thing. So, how did we actually go about exploring the possibilities of TFS release? We didn't start setting it up like for our development environment. We just said, well, if we're going to use it, we really need to make sure that we can go from development all the way to production. So the first thing we did was we set up a small POC, where we created a small Hello World website, packaged it, put it on a development server, or deployed it to development, deployed it to UAT, and then deployed it to production. Well, in our case, a DR environment, but that has a similar status as production. Because what we learned from other things in the past is these domain boundaries between development land, prod land, between UAT, prod with policies, with authorizations, they usually are the biggest showstoppers, if you would say. These are usually the most difficult things to overcome. So that's what we first set out to get our POC to work and just prove that we can deploy to a production environment. Simple thing, hello world, there it is. And once we did that, we actually continued expanding our release definition. There are a lot of release tabs that come out of the box. There's a big marketplace for release tabs that you can upload to TFS. But, well, of course, what we needed to do was not available. So there it really helped that we had an easy to extend tool. We created like a number of release steps. For example, for deploying SSIS packages, for deploying SSRS reports, for copying files across just to the server, because the default way or the default step that's used to copy has some problems with policies and authorizations. So we thought we could create something to work around that. And then at some point we were more or less ready so that we could actually deploy the whole system. And what we learned from that is during our proof of concept where we deployed to production, we borrowed a few agents that were in the UAT and Potland. And that works, but what you really don't want is agents that can basically get onto any server in the network, because that's a big risk of, well, if you make a typo in your target machine, you can possibly, break another system. So what we learned, we need our own agents. We've had someone create agents for us, get our own service accounts, get these service accounts permissions to our own servers, like differences between UAT and production, so that we are at least, we know that our agents can only target those machines and will not interfere with other systems. Another thing we learned, painfully, a lot of the infrastructure we use, and with infrastructure I really mean servers we target, they're all different. And well, if you want to have a repeatable, predictable process, it's not really, it's just a real pain if you cannot be sure what you're targeting. So that's what we learned by this whole exercise, moving from XL deploy to TFS. Infrastructure, it's not predictable. And that's really something else we're going to put on our backlog to get more control over our infrastructure, so that we can basically determine ourselves, for example, how SQL is installed, what version of PowerShell needs to be on there, how IIS needs to be configured, all these kinds of things. We want to get more control over it. In the past, it's basically been the same as what I told you in the beginning. If you want to provision a server, we have a set of software that needs to be installed. We have a big run book. It's handed over to a DBA and a Windows engineer, and each server ends up being different. And that's something we really learned. We used to have it with XL deploy, but obviously this is not particular to TFS, but this whole exercise made it very apparent that this is a problem. true. It's no different from XL deploy, these kind of things. But I guess apparently we already did some tweaking in XL deploy to work around these kind of things. And when you start from scratch, yeah, these things hit you in the face sometimes. Another thing we noticed, which is also in XL deploy, is configuration craze. We gathered all the configuration items we have in the variables tab for one environment, and we found out that we have 300 plus items in there, which is ridiculous. It's not maintainable, it's duplicates, it's things in there that are not even really configuration because they're the same across any environment, like database names, they don't change. Another item on our to-do list, get rid of a lot of these configuration items. So no matter what the outcome of our migration is, this is another thing we need to take care of, because this is just a maintenance burden for us. In all of this, we also learned a lot more about our deployment process. So we found a lot of steps where we can actually improve, make things simpler, make them more robust. The RDW data warehouse where I'm working basically consists of 2 data warehouses, one for liquidity and one for credit risk. For a long time they've worked separately. Since a bit more than a year we are sort of integrating, and what we want to achieve is that we both deploy in the same way. So all the components we deploy, we want them to deploy in the same way. We want it to be transparent what's going on, because in some deployments it's really not transparent what's happening. It's just files, PowerShell scripts wrapping other scripts and doing a lot of stuff. And if something goes wrong, it's very difficult to dig into all the logs and figure out what's actually going on. So that's another thing we've learned in this whole exercise. We want to be transparent. It needs to be clear, really, from the logging, what is going on. And if something goes wrong, it needs to be clear what goes wrong. Because we don't want to spend hours and hours searching. We just want to get it up and running as soon as possible and fix the problem, hopefully make it more robust. And then there's one thing left that I took from this whole exercise moving to TFS release. That's the release definition and combined with the environment. If you know XL deploy basically has a manifest or an application you want to deploy, a manifest with deployables, which is your recipe and your ingredients, and it has your environment, and you can just say, use that one, put it on that environment, and just go. TFS release has a bit of a tight coupling between environments and release definitions, and that's something I don't like about it, because it means you create a release definition, you need to configure all the environments that it's going to target, and then you maybe have another component which you put in a release definition, which is going to the same environments, and you need to configure all those same environments again. Instead of just saying, hey, this is my recipe, this is my environment, just put them together and go. And that's one thing we're actually struggling with a bit, how to organize that, how to show that in TFS release. Because we really have a lot of environments. We have, I don't know, maybe 30 or 40. And you don't want to have a release definition with 40 environments listed in it. It's not really, well, I at least think that doesn't really work very well. For me, it would be a lot easier if I could just say, here's my release definition, here's my environment, go ahead, deploy. And you can always maybe separately set up a pipeline where you can more or less orchestrate a whole path. But that's something that we are actually struggling a little bit how to work with this. So, milestones. What have we achieved so far? Well, what we've achieved so far is that we actually have TFS release ready to deploy to production the next release, which will be in, I think, a week and a half. So we can deploy to development, we can deploy to UAT, and in 12 days from now, we will know if we can deploy to production. So that's something we've achieved. I think a lot of people are very eager to know if it's going to work. We've gone over all the configuration items multiple times. Hope they are okay, because that's something you can't really test up front. We did do some tests up front with production environments, at least to make sure that our agents can actually access the machines, access the databases, these kind of things. But in the end, releasing to production, the proof, I guess, will be in tasting the pudding. Another thing we did achieve with all of this is our contribution to the marketplace. Like I said, we created a few custom release steps. I think Mario has already published 2 of them on the marketplace. And we have a few more that we can publish, but that need some real good documentation to use. And we also made an improvement on an existing deployment step. There's a deployment step on running SQL scripts against a server, which would only use SQL authentication, and we extended it so that it can also use Windows authentication instead. And that's also something we want to, well, give back to the community as a pull request. And I heard this morning from Mario that the 2 release steps were, well, the release steps we had in the marketplace are already used, they're downloaded, and we already also got feedback on them. So it's really good that these things are validated by the community, and that we get some feedback on how to improve on them. I think that's that are the achievements so far. Those are our milestones. So next up is release to production and see how we can how that goes. Thank you. Not sure there's time for questions if anyone has. Oh, sorry, yeah, in the back. Sorry, I'm not sure if I understand what you mean.
You mentioned that more control amount of tools, versions,
yeah.
Installing yourself. Aren't you worried about the agent, like you said?
There's this possibility, but I think, or we believe that the advantages will be greater than the burden. It's not that we're doing really fancy stuff. It's most of the stuff is out of the box, but we just want to make sure it's there on our terms. So SQL is installed the way we want to install. So with all the options we take, IS or PowerShell just has the correct version. It's either installed before we deploy, or it just says, well, we can deploy here because there's PowerShell version is not the one we want. Yeah. Yeah.
How many people will you reuse for deploying?
We did have to rewrite quite a bit. Obviously, the plugins that are available in Excel Deploy for deploying SSOS reports, SSES kind of things, we had to rewrite them, which also gave us the opportunity to improve on some things. But we also left a lot of stuff as it was. So all the wrapping with PowerShell scripts. yeah, we just left that. We just called it the same way it was called in Excel deploy. We're just executing PowerShell script, and we thought, well, that's for later. Then we will go and dive into that and see if we can improve on that. So it was some things we had to do because there was no option for that, and some things we could just leave and keep for later to improve on. Yeah. I don't know, when did we start? I think somewhere September, August, September. So we're now half year. Basically learning everything, creating all the release steps that we need, and being in a position where we think we can deploy to production. Yeah. Yeah, go ahead. Yeah. Yeah, I think, yeah. You can also use it on Unix servers. Yeah. Yeah. Well, that's an interesting question. Support is, I think, well, Aaron knows about that. The question was, how is support for TFS inside the bank? Well, TFS, it's fully supported.
Not know what the value supported you have questions on the tool, how to do things.
Yeah, that's a good one. Probably you need to find a community or the people who know about this. There is a team that's Aaron's team is currently running TFS, but there's also another change going on, is that we're moving to VSTS, which I think is off-premise cloud.
TFS in cloud. But certainly if you need help setting up VSTS, we help. So
yeah, and
so that's part of the community is really accepted to help teams improve their CI/CD process.
Yeah, we're ready. And yeah.
When there was IPYT, there are at least these processes that was building the community. So we get some knowledge about certain processes or things now with the changes things got a little bit unclear, but I think so many ways to get out get Brody and then right person.
He's left the building.
Yeah.
But obviously, also the online community is, I guess, a bit bigger than the CBR community. So it will probably be easier to find your answer there as well. Right. I'm not sure how we are time-wise.
So there's one more.
Last question. Yeah. We never use Excel release. We never got to use that. No. We have no experience with combining these. No. Right. Okay. Thank you very much.
Ja.
Moet je ergens anders heen?
Ik ga ergens anders heen. Je houdt hem gewoon hier zo, dat is het anders. Hè?
Hoe lang houdt hij nog uit?
Oh, 2%. Dan iets flauwer. Nou, dat klopt niet. Dan doe ik
Ja.
Ja, ik vraag me ook af van, er komt ook niemand in en zo. Dus...
EM100 stroef.
Ja, zo is het. Een beetje vaag verhaal. Zouden nou mensen op deze hangout moeten aanhaken eventueel? Of is het
Ja,
of
maar
op de YouTube eigenlijk?
Ja, beide.
Oh, beide, want...
De hangout en op de YouTube zit er nu 7.
YouTube wel? Ah, oké. Hangout bij een game heb je dus.
Ja, die andere van mij, maar die staat nu even dicht. Anders kregen ze daar kijkers. Dus even
You can put it on your laptop.
Ja, is goed. Oké, maar hier hebben ze wel chat erbij. Maar die bekijken wij dus niet. Die bekijken dan of zo.
Wat zei je?
Oh, hier zit er een chatfunctie bij ook?
Ja. Ja, dat was diegene die zijn microfoon op zijn laptop op had staan. Ja, als je kan wel de PowerPoint opzetten. Alleen dan moeten ze vooraan aanmelden op Hangout.
Ja.
En dan hun screen sharen.
Oké. Ja.
Zo heeft ze bij de laatste spreker kunnen doen. Ik had het zo laat binnen net dat ik niet aan kon melden. Hopelijk zou ik bij de laatste keynote spreker even kijken.
Ja, precies. Ja. Ja, is goed. Ik weet het al, maar daar die ernaast staat, met een bril op.
Data warehouse. Nou, dat is wel fijn. Nee, dat is toch hetzelfde als net?
Gebruiken we dit ding?
Ja, die zit erin, is goed.
Ja.
Oh, kijk.
Hij
Hij
zijn
doet
allemaal
het.
verstaan. Dan gaan we even... Kom ik nou weer dat...
Daar komt die. Hup. Windows Media is het.
Aan de application blueprints.
Ja.
Verder zijn er in MIST release pipelines gedefinieerd, die bepalen naar welke omgevingen een gewijzigde app...
Zo, laatste keer.
Drie keer een scheepsrecht.
Doel van CI/CD is betere code die sneller naar productie kan worden gebracht. Hiervoor hebben wij een geautomatiseerde bouw- en testomgeving ingericht. CI/CD wordt getriggerd door een wijziging in de code. Hierdoor start een Jenkins-job voor de build van het project. Deze job gebruikt Maven om het project te compileren. De gecompileerde code wordt opgeslagen in Nexus en er wordt een signaal gestuurd naar MIST om aan te geven dat er een nieuwe build beschikbaar is. In MIST worden softwarecomponenten gebundeld verwerkt in zogenaamde application blueprints. Verder zijn er in MIST release pipelines gedefinieerd, die bepalen naar welke omgevingen een gewijzigde application blueprint wordt uitgeleverd. Alle configuratie zoals endpoints is opgeslagen in MIST. Vanuit de release pipeline wordt de application blueprint gedeployed. Na het deployen wordt een Jenkins-job gestart die de gewijzigde software automatisch test. De pipeline gaat verder naar een volgende stap, bijvoorbeeld een deploy naar keten. Als er fouten zijn, stopt de pipeline en gaat er een mail naar het DevOps-team. MIST zorgt voor de samenhang van alle losse stappen. Zo is het mogelijk binnen zeer korte tijd nieuwe software te deployen. Wij gebruiken MIST voor CI/CD, maar MIST kan nog meer. Met behulp van MIST beheren we ons serverlandschap. Met MIST kunnen we geautomatiseerd nieuwe servers uitrollen. Dat gaat snel. In 2 uur hebben we een nieuwe server ingericht. Voorheen duurde dat soms weken. We gebruiken MIST ook voor het beheren van onze machines. Het uitrollen van Oracle patches over alle omgevingen doen wij nu geautomatiseerd en gecontroleerd. Samengevat, services kunnen altijd binnen een paar minuten naar keten, in plaats van enkele keren per dag. Deployen naar pad en ook prod gaat op dezelfde wijze. One-click deploy dus. Met druk op de knop start de build en wordt de code automatisch gedeployed en getest. IT voor IT.
This is
Not this one. This one.
So welcome. Now that you have seen the introduction movie time-lapse a few times, we can give you all a warm welcome. The short time-lapse you just saw was more a summary of what we achieved and what we do with MIST. And we created it for our IT for IT presentation, and we're happy to share it with you today. Well, I think most of you speak Dutch, or at least understand Dutch. So I think you get the point of the meeting. My name is Rob de Haan. I'm a solution architect in the CRMI platform infra and lifecycle team. And I'm responsible for CI/CD and test automation.
My name is Harry Koppers. I'm the product owner of the Oracle BPM platform. This is a platform which gives Rabo the opportunity to help automate processes in the bank. I work with Rob together in implementing MIST in the process of developing software and creating new environments.
So just a quick note on our department, Access Middleware Services. We are responsible for developing, delivery, and maintenance of several Oracle Fusion Middleware platforms. Two of them we will discuss today is OSB, Oracle Service Bus, and Oracle BPM Suite. So development of services is done in commission of business projects from other domains. This means that CRMI or BPM does not have ownership of the services and processes we develop. So we have several business teams. Those are responsible for development and testing and operating the services, and the platform teams who are responsible for maintaining and operating the environments.
Oracle Business Process Management is an Oracle product on top of which applications are built which support the processes in the bank. Can be divided into two major portions. One is supporting local bank processes, and some of the processes we support is when somebody moves from one address to the other, which is within Rabobank quite a laborious process. We start about 11,000 processes every week. Change of organizational data. Once at the Chamber of Commerce something changes in the registration of a firm, we want to know about that, so we pick up these signals and then start changing the data we have, Rabobank has of these companies. And other life-changing events like birth, marriage, decease is also supported by these processes. In online banking, we support the product sales process. If I acquire a product of the Rabobank online, it is handled by the BPM process, which consists of about 25 applications and starts about 90,000 processes every week. We have 3 teams working in this environment.
A quick note about CRMI. We support other Rabobank domains like online, klant, verkoop, verzekeringen, and so on. We have services running on Oracle Service Bus and on SOA Beeple. Just to give you a hint of the numbers, last year we processed over 2.3 billion service calls, so that's quite a lot. And one nice thing to point out is last year we made the Ivan Check API service operational, just mentioned today by Wiebe Draaier on Dutch National Radio as one of the latest Rabobank innovations. This is the check that is executed when you enter an account number and a name in your, for instance, your mobile app. Then it's checked on a cloud service whether or not the two match. So we started halfway last year and we processed around 200 million calls, and today we average on 10 million calls a week. So this is about the numbers that we process.
Where do we come from? Which was the old situation we came from? If we needed a new server, the server was manually provisioned. So we asked a typical change process, would you please give us a new server so we can install our package and then our software. This was time consuming. The environments which we got in that way were slightly different. They were never the same. The whole process is error prone. Every time somebody else is doing work which introduces small mistakes, and this made it very difficult if there was a problem in an environment to find out where the problem exactly was, because the environments were not the same. Then, considering the software that we deploy, our applications, this was also a manual process. It was done by a custom-made framework. This custom-made framework we had to build for every environment. So instead of build once, deploy many, we had to build many and deploy once. error prone because it was all made at the place. The framework was very rich, so it was very tailored to our situation, but very difficult to maintain it. You needed special knowledge to maintain this framework. And we had a split responsibility between development and to deploy it to an environment. So when the developer was finished, you had to come to our platform team and ask, would you please deploy this software and do these and these steps to make it available to me? Where do we want to go? We want to go to a fully automated process. And one of the slogans which is driving us is twice as fast. It's one of the goals set for this year for Rabobank. We want to make our process twice as fast. So we want to automate the provisioning. If we want a new server, push button and a new server is there. And we want the software to be delivered in automatic pipelines. As stated, CI/CD, push button to test and bring it to the next environment. That needed automated testing. If I want to do this process automated, all the testing has to be automated. We wanted out-of-the-box tooling. Instead of writing our own scripts, use the tooling as it's delivered by your supplier. It should conform to market standards because we have a lot of people which are coming from outside working within the Rabobank. So it's, the best way is to adhere to standards used in the market. And as less as possible custom scripting. Where we came from was a situation where we had a lot of custom scripting, which is gives you the opportunity to tailor to your own process, but it's very difficult to maintain.
So why Mist? CI/CD has been around for quite a few years now, and there are already a lot of tools available on the market. So why is there a need for Mist for us? We had a tool selection process, and we had a number of requirements, obviously. And one of the key requirements was that we were looking for a tool that would support both automatic platform provisioning and automatic delivery of our software. So we compared a number of tools like Excel Deploy, Flex Deploy, Mist, and Oracle Enterprise Manager Cloud Control. And it appeared that Mist was the only tool that would support both automatic platform provisioning as well as automatic delivery. So we did a POC with Mist, and we focused initially on provisioning. Well, that was successful, and we decided to buy the product from an Australian company called Rubicon Red. And Mist basically consists of two parts. We have Mist CLI, which is basically the command line interface, so to say, the engine. Had been around for a few years, and its main job was platform provisioning and maintaining. It also supported, in a way, delivery, automatic delivery of software. Release management is in Mist Studio. Mist Studio is the UI, which is a Java application running in the browser. And so all commands that are executed in the browser are transferred to Mist CLI. So we worked with Rubicon Red to improve the product. That took some effort from our side. The advantage we thought to gain was that we could tailor the product to our needs. So if we have to use out-of-the-box tooling, we better make sure that the box contains what we need. So what is Mist? Mist is an acronym that stands for My Simple Toolkit. That's the way it started. It's a product that is developed and delivered by Rubicon Red, which is an Australian company. And it is fully aimed at speeding up delivery of Oracle middleware platforms. It does so by supporting both platform provisioning and automatic delivery of software. Platform provisioning is done by creating a so-called platform blueprint. That's a template which is based on the Oracle Enterprise Deployment Guide, so it follows the market standards for Oracle middleware environments. Based on the platform blueprint, where you define the scope of your system, basically, you can define platform instances, so to say your chain environment, UAT environment, production environment. The trick is to define as much as possible configuration in the blueprint, and all the models will inherit all the configuration. So the thought behind that is to keep configuration drift, so differences between environments, to the absolute minimum, or better to say zero, and to do only the environment-specific configuration, like username, passwords for data sources, and so on, in your platform models. So that's the platform provisioning part. Automatic delivery is done by means of so-called release pipelines, which is basically a collection of stages you define in Mist where you want to deploy your software to. And obviously, the release pipeline, the stages that are in the pipeline are the same stages that you define in your platform models.
Provisioning, where did we fail? We started out the process, and like we heard earlier today, we had a brochure. Configure everything in minutes. That's what was promised by our supplier. That proved to be true for a simple environment, which was conform enterprise deploy standards as provided by Oracle. However, the Rabobank has a more complicated environment, and you can't deploy things using the next finish buttons. So we started working on provisioning, and it didn't go well. So we decided to invite the people, our provider. We decided to invite him to come to our office and to work together to see whether together we could come to a good provisioning. This engagement took about a month, and in this month we succeeded in provisioning 80% of everything we wanted in the environment to get this done. There was 20% left, and these last 20% took a very long time to get to the final result. What did we learn from that? So we failed initially in putting up the provisioning very fast. We learned from that in the command line interface, as Rob stated before, it was very rich. You could do a lot of things, but we wanted to use the Mist Studio. That was the aim. And the Mist Studio was not as far, not as mature as the command line interface. For instance, Mist extensions, which were provided to get functionality which is not yet in the product. This was not available at when we started. So what we did was make scripts to do the things the product couldn't do yet. And this was a very great feature of Mist, where we can solve the problem without disposing Mist. But hey, our goal was to get rid of all the scripting, and now we were scripting again. So that was counteractive.
So what did we learn? As Harry said, we had an engagement where a Rubicon consultant was on site at Rabobank. So that really proved to be very efficient. And we came up with a long list of feature requests for product improvements. And we learned that the supplier, Rubicon, was very willing to listen to our suggestions for product improvement. We had to explain them sometimes why we needed certain features, and the reason why certain features would not be in the product mostly was simply because it wasn't in there yet. When they started Mist Studio, they focused on the basics, so to fill out the 80%, and we came up with all kinds of exotic functions and configurations that we want to model, which were not in the product. So as Harry said, workarounds, custom scripts, keep away from them if possible, because they will impede future upgrades. For instance, if Oracle decides to release a new major version of Service Bus, then Mist is supposed to support that new version as well. However, if you have custom scripting, which is mainly WLSD or Python scripts, and you have those incorporated in your models, they don't get automatically migrated as well. So that's the reason why we want to avoid those scripting. Other things we learned is we have at Rabobank, as Harry pointed out, not a next finish type of installation. We have a lot of custom configuration specific for Rabobank, which does not adhere to market standards. And as it proved to be, as long as you stick to the standards, there's a far more bigger chance that you that it will fit the product. Scripting we talked about, we learned that provisioning itself, once you have the models completely modeled out, is very fast, but the initial effort to get there was quite high. And what we also learned, and we learned from BPM as well, is that the more mature your platform blueprints are, the more you get inherited into your platform models, so you have less to configure. Talking to Rubicon made us also have to talked to Rabobank internally to set expectations at a different level, more realistic. As it turned out, we took a bit more time than initially expected to get the whole provisioning bit running. The big success, however, came for us when we had stability problems on our existing service bus platform. And we decided that the only way to improve that really was to use Mist to provision a completely new service bus mirror consisting of 6 managed servers that would execute side by side next to the existing environment. That proved to be highly successful, and then the big success was there. And after that, we continued with reprovisioning all the existing and other environments like chain and pod. So moving on to release management, this is a typical CI/CD cycle that we implemented for both CRMI and OBPM. Simple start on the top left, a developer changes code, pushes that to Git. We have a Jenkins job that builds the code, stores the compiled artifact in the Nexus repository, which is used Rabobank wide. And the build job also pushes the new artifact, the new build number to Mist. And in Mist, that event triggers a release pipeline that will start deploying the application to the first environment in the delivery pipeline, which is the CI environment. When deployment has been successful, Mist triggers a post-deployment job, which is also a Jenkins job. And that Jenkins job in its turn will start any necessary test jobs that are already existing, like SOAP-UI test, fitness test suites, or WSDL stop, which is used in Rabobank as well. So this is the solution we were trying to achieve and which we have in place now. On the bottom left, you have the developer pushing code to Git, the one-time build exercise by the Jenkins job, storage in Nexus, and Mist retrieving the artifacts from Nexus for deployment to each and every target environment. So it's important to notice that all the code is in Git and all the configuration, so endpoint, queue names, policies, and authorization settings are all in Mist. And those are the environment-specific settings that you want in a tool like Mist. So using Git, Jenkins, Maven, and Nexus was pretty straightforward. That was already in place, a lot of experience within Rabobank. We could reuse our existing testware, like the SOAP-UI test and fitness. And we had all proven tools except for one, which was Mist. And the setting up the delivery pipeline in Mist was a different chapter. And it appeared that the release management functionality that was in the product at that time was quite immature, more to say, fairly non-existent. So we expected Mist Studio being capable of deploying software, and to be honest, it could. We also expected that we could roll out Mist for usage in DevOps teams rather quickly. And in practice, that was definitely not the case. So release management capabilities, although we could deploy software, was practically not usable. It was impossible to define 2 release pipelines. As some of you will know, we frequently use different testing environments. We have a chain 3 environment, alternating release, we have a chain 5 environment, and that flexibility was not in the product, so that could not be modeled. And to make things worse, all the environment-specific settings, like the endpoint and so on, you had to enter in Mist each and every time you wanted to deploy a service to the same platform again. So it appeared that we were a really launching customer for this release management bit, and we definitely needed to get closer to Rubicon and get them back to the drawing board. The way to do that was to conduct another engagement. We had the same consultant on site again. And before he came to Rabobank, we defined an extensive set of use cases with all the functionality and proof points that we needed. And we performed a gap analysis during the engagement. Only a few proof points could actually be proven. And the consultant went home with a detailed list of requirements, for release management to get working. So the expectation management we had to do was, again, we cannot roll out Mist yet to our DevOps teams, although that had been broadcasted to a certain extent. And we identified the minimum viable product, which is the minimum set of requirements that have to be fulfilled if we can actually use it. So again, the process of rolling out Mist got delayed. Rubicon also works with sprints, and a few sprints and a few months later, they came up with a new release with the improved capabilities we asked for. We needed them really bad. And with that new release, we started a pilot. And during that pilot, we identified an initial set of services that we wanted to deploy to production. We also involved some experienced test engineers to incorporate the existing testware in our release pipeline. The result was that we were successful in deploying services and testing them into production. That was the starting point to move on and to roll out to the DevOps teams and to gain more experience. So that was the first experience with release management for CRMI.
At OBBM, we also wanted our experience with release management, and we started off on the wrong foot. We had one engineer starting this process, and he had set the aim for himself to have this implemented in 2 weeks. So we started at the beginning of 2017, and he worked very hard, but he didn't get anywhere. We thought we can lean on the process which CRMI already has implemented. It was not completely true. We had several artifacts which we had to deploy. So the experience of CRMI was usable, but not broad enough. BPM is a more complex environment than the CRMI environment. We were provisioning and release management with Mist. And we again hit the limitation of the product, and of course we were blaming the product and the producer of the product. It's a bug, and in many cases, yes, it was a bug. Should we reconsider our way of working? No, we have our way of working. This product should support our way of working. This led to frustration. And this frustration, blame the vendor. The vendor is not listening to our requirements. They don't understand what we need. That was the atmosphere at Rabobank. And to make things worse, we wanted it to speed up the whole process. So we were increasing the pressure on the vendor to get things changed. And that didn't work. So we came up with the solution which helped us twice, and that was another engagement. So the engagement started. This was in the end of 2017. So our engineer was in the meantime probably frustrated about what was happening. And at the start of this engagement, you can feel the vibe between the expert of the provider and our engineer was not good. So we put them together. We kept them together for a few days. They started discussing with each other, and slowly you could see that we were trying to implement our Rabobank way of deploying, using a product, and this product, there was a certain way of thinking behind this product, which was not the same as we had. By putting these two people together, they discussed and they got to respect each other's views, and in due course, we understood the product better, Rubicon understood our wishes better, and the consensus grew, which was a very important point that we got this consensus. What did we learn from this process? Be agile, as is said before today. Don't try to implement your way of working exactly as it is. Talk to the people who made the product you're using and try to come up with a way that suits both. Be open for new ideas. Don't stick to your own ideas. Have an open mind. You can't have your cake and eat it. That's to say, you can't have everything at once, and you can't have all. Hey.
Keep talking, Harry.
Okay. And very important, one lesson is do it face to face. Avoid extensive email actions. Sending frustrated emails only sends wrong signals. Set people together. These guys had to come from Australia. They came from half around the world. They came here and we talked to them, which is an advantage because since he was here for 2 weeks, we could send people out with them in the night to have dinner or drink a beer, which always helps to clear up a misunderstanding. So it's much better to sit together and get an understanding of each other. By the way, we did this with a vendor. It's a company which produces this product. We have the impression that if you don't have a vendor, but you use open source product, join communities, discuss with people about what are ideas and how people are doing things.
Okay, so once we got the BPM release management exercise on its way, in the meantime, we were at CRMI rolling out our release management functionality to our DevOps teams. So we had some new challenges there. With the DevOps teams, the DevOps operation, teams got other responsibilities they didn't have before. In the past, they could lean on this custom build and deployment framework that would do all the work for them in terms of deploying and making sure that scope is guarded and so on. Now the team was completely responsible for deployment all the way to production. And, well, they had to put in some initial effort, and they thought, well, this takes extra effort from us to get things working. So initially we thought we let the teams do deployment all the way to pod and have the experienced ops engineers do the deployment into production, because they know exactly how and what and when and what to do when anything goes wrong. However, in the past, when we had a release package, so the build for production was accompanied by release notes and tech notes describing what to do, what policies to implement, and so on. But that's non-existing anymore. So it saves us a lot of time, but the result was that the ops engineer who wanted to do the deploy had no idea what he was deploying. So he said, well, I can push this button, but no idea what will happen. So the knowledge of what would actually be deployed is in the team, because they have done the whole process up to pod. So we decided to give the teams the responsibility to actually do the deployment in production as well, and give them the support whenever they needed it. So initially we focused merely on the tools, getting the process in place, getting all the functionality working. So, but we neglected the process and how the existing way of working would change. The learning point for us. Then there's documentation. It's all on Confluence. Is the big thing. We really had a lot of documentation, very extensive and very detailed. But as we found out, the DevOps teams thought it was way too much to read and far too much detail. So once I was reading the pages, and I found a page of one of the engineers who said, well, there's a lot of documentation, but it's way too much to read. Just do this and start working, and if anything goes wrong, we'll ask. So we noticed that sharing knowledge is more than just putting documentation on Confluence. There is a lot, but if it's overkill, it doesn't do the job. So from that point on, and also a bit earlier, we put a lot of effort in educating the teams. We had demos, we had developer sessions, and we exchanged thoughts on how to operate Mist, how to operate a release pipeline, what to put in one release package, and so on. But the conclusion is just keep it as simple as possible. Let the teams do their job, let the teams do their work. You cannot enforce a specific way of working to the team. You can only give an advice. And, well, we'll just see how things go. So for the DevOps operation, there was also the expectations that needed to be adjusted at some point. So we came from a tailor-made environment to a situation where the teams were fully responsible. And they thought initially, well, I thought Mist was doing everything automatically. Well, it can, but you have to provide it with the right input. Also, the way CI/CD continuous delivery is designed, is thought of. We had engineers complaining that they had to go to CI first and do tests because that would delay them proceeding to chain. They said, well, if it fails in CI, I cannot proceed to chain. Well, obviously it fails for a reason, so you better fix it and then do it again in CI, and after that you can proceed. Another argument was, well, I have to go to CI, but there is no testware yet. Okay. Make a minimum set of testware, or even if you have only 1 or 2 happy flows, that's better than nothing. So they learned a lot, the teams, and now at this point in time, they are really happy using Mist. On this side, yeah. But once they started using it more intensively, we ran into problems. Mist appeared not to be very scalable the way it was configured. So we added more users, we added more release pipelines, we loaded a lot of properties, and bam, the whole performance collapsed. So the failures were in the database, in the application, and the configuration of the Docker containers. And there was hardly any support from Rubicon in terms of advice on how to improve. The good thing is we found out ourselves, and we provided the supplier with the information on how to improve their product. So it's a bit the other way around, if you ask me. So, but sometimes we have to instruct the vendor what to do.
But in the end, what's the conclusion of all the effort we put in it the last year? The investment has paid off. The modeling and configuring of new environments goes very fast. Once we have these blueprints and models, it's really a push button and the system is ready for taking the software. The upgrades of the platforms, patches to be dispatched, things like that, go very fast and structured. Very often it's a very big problem to get all the patches to all the environments, and you lose track of which is where. This is solved by this way of working. The knowledge to do this, we very actively steered on in the teams who were responsible for this to not let heroes develop. There's always somebody who is fast on finding out how things work, and we sometimes tend to let this person do all the work after that. We very actively steered to dividing the work over everybody so everybody could get some knowledge of this. As release management is concerned, we now have self-service for deployment by the DevOps teams, which is a very big relief to them. This is fully automated, so once they check in the code, it goes to all the environments. That leads to a low time, a short time to market if we have new functionality wanted by the business, very fast. We have a nightly regression test. Every night all the code is subjected to a set of tests to see whether everything is still working correctly. And most of all, we have happy users, which is a very important thing, and we have happy customers. Finally, where are we now? We, as provision is concerned, we have 28 Oracle Service Bus environments, going to 42 which are provisioned, nearly 200 Linux services which are maintained in this way. Lifecycle management work is in progress, so to keep the systems on schedule. And right now we have 250 CRMI services which go into our CI/CD solution for the next 2 months. That's for CRMI. For OBPM, we have 14 OBPM environments, about 70 Linux servers provisioned automatically. LCM upgrade is in place. We are deploying the fixes using this platform. CI/CD, including deploying Mist, is in place. And we deployed our first application to production on the 1st of February. The next one is going this evening, and there's more in the pipeline.
And we're done and out of time. Time's up.
Time's up.
On the spot. Any questions? Yes.
Did you run into problems or limitations with regard to the change process in place of Rabobank?
The change process, yeah, we try to limit the use of the change process as much as possible. So we managed to keep most changes as a low impact change. So there's no big change procedure. We don't have to go to the change board for the most services we deploy. Administration has to be done, yeah.
But our experience is that administrating a change request is very fast. It's you have to be very careful what is in the change, to who has to agree on the change. So if there are things which need the board, you need to plan in advance. But the usual functional changes can be done very quickly. Sorry, Art? No, the question was, are the changes automated? No, the changes, to make the changes, still manually work. Yeah. Time's up. Okay. Okay. Thank you very much.
5 minutes break and then the last.
Okay. Thank you. Thank you.
engineer.
Ja.
En dat doe ik al inmiddels al 4 jaar.
Zal ik hem meepakken vanuit dat we onderling al elkaar ontmoeten via de Utrecht Meetup? We hebben het DevOps Meetup gehad hier bij ons in het kantoor.
Ja.
Daar waren jullie ook. Vrienden van...
Ja, ik heb een variant van dit praatje ook al eens gehouden intern bij jullie, zeg maar.
Ja, goed zo. Ja.
Dat zit eigenlijk.
Ja, dus dan kan ik bol.com als een van onze vrienden... Bankieren jullie bij ons?
Sorry?
Bankieren jullie bij ons?
Ik heb werkelijk geen flauw idee.
Ik ook niet. Nee. Als je dus hebt de neiging om achterlangs te blijven lopen.
Ja.
Maar als je dat doet, zit je de hele tijd verkeerd in het licht voor het beeld. Terwijl als je hier gaat lopen, dan zit die tafel hier. Snap je het wel? Ja, je loopt gewoon heen en weer, maar ik snap de zitten. Ja. Oh, zag iemand die? Enorme gaaf. Mensen van infra gesproken had?
Dit is van Jochem.
Hier, sta je zo.
Oh, yeah. So we're with a little We're with a little less people. Still, room is pretty much okay. I hope there are some people outside still. Okay, we can go. But there are people who have done some tests, IQ skills test. We have a high score, but it's you can test as many skills as you want. There are people who have done 3, so you can still win. So if you want to, after this talk, then you can still try, and then we have a winner. I would like to present to you Maarten Dirksen. Maarten is of bol.com. We haven't met, but we've met bol.com at the local meetups, DevOps Meetup Utrecht, where we had nice chats, where we all also have personal friendships already. And they have a very good story that allows us to learn. So we thought, why not invite him? Therefore, welcome. And I hope you enjoy it.
Thank you very much. Right. First of all, thank you to the organization for inviting me to give this presentation. It's really nice to be here and to be able to share with you what we've learned over the past, shall we say, 4 years at bol.com about CI/CD. Now, the title of my talk in the program is Setting Developers Free. The title you see here is CI/CD at bol.com. Those things are very much interrelated because I work on a team that provides the CI/CD tooling at bol.com, and it's our experience that is actually what can set developers free to do what they do best, and that's develop software. So I'll get back to that in a moment, obviously. To start out with, I'll tell you a little bit about me and about bol.com, in case you have never heard of it or don't know what it is. Then about the CI/CD story at bol.com, how we started out 4 years ago when I joined the CI/CD tools team. Then the current setup, and then I'll tell you a little bit about Mayfly, which is an internal CI/CD framework that we developed and have now abandoned. And then about the future in the cloud. We are moving to the public cloud as bol.com, which is very exciting for us. Obviously, we're not the first ones to that particular party, but gives us a lot of opportunity to do a bunch of new stuff, and I'll be speaking about that. Let me just start my timer to be sure. Yeah. Right. So about me. My name is Maarten Dirksen. This is my Twitter handle. Should you care to follow me on Twitter. I've been in IT since about 2007. I started out as a Java engineer, just writing Java code. Then about 5 years ago, I joined Bol.com, and after about a year of whining about our CI/CD setup, the manager of that team got fed up and said, "Well, if you know better, come and show us." So that's what I've been trying to do for the past 4 years. I got heavily involved in the whole container scene, shall we say, back in 2014 when Docker sort of first became big. We're trying to introduce it at Bol in a good and constructive way ever since. And yeah, my hobby is local politics, and that's what you see. Is there some sort of pointer thing? Well, that's in the picture. So this is me doing local politics. This is not me doing community service because I was arrested for something, just to make... Someone the other day at some meetup said, that looks like a taakstraf. If you don't know what a taakstraf is, ask some Dutch person. Not a taakstraf, this was purely voluntary. Anyway. Oh, right. So I come from a city called Leiden. And in Leiden, we have a huge party every year called the 3 Oktober Leidsontzet to celebrate that in the 16th century. I have to be careful with this one. I think 1573 off the top of my head. We were liberated from the Spanish by other Dutch people. And on the evening of the night of the 3rd to the 4th of October, the gemeente reiniging, municipal cleanup services, go into the city and clean the whole thing up so that people can go to work normally the next day. And local politicians, they volunteer to help. And it's just because we love the city and not for the photo op at all, I assure you. So, anyway. Right, so Bol.com, as I'm sure you, as I kind of assume that most people in this room would know because you're employees of a Dutch company. We are the largest online retailer in the Netherlands and Belgium. Yeah, we have 55 plus and more or less always growing Scrum teams in the company, in the IT department. Obviously, we have more than just an IT department, but the IT department used to be the biggest until they hired a whole bunch of people at marketing, and now marketing is the biggest. But, we have a really strong Scrum culture. We've been doing it since 2009, since Scrum basically came in and saved a huge project that was going terribly. And we have this kind of love affair with Scrum. We've had it ever since, and people are really dedicated to the whole Scrum culture inside the company. We have about 200 plus services and backend applications, mostly Java with an Oracle and more and more Postgres database backend. And we have a mix of teams that do fixed sprint rhythms, and they can more or less decide themselves what kind of rhythm that should be. And teams that just deploy whenever they feel like it. So we literally have teams that run on a 2-week cycle, and we have teams that run that basically deploy multiple times a day. Right. So, okay, I'm going to, as we say in Dutch, stroop de mouwen op. This is where the talk gets serious. I'm going to get out on a limb here because right before I gave this presentation, I thought of a metaphor because my talk is about developer freedom. I thought of a metaphor which is either really, really, really apt or is completely overblown and inappropriate. I'll let you decide which one. I'll let you decide which one it is. So, raise your hand if you've heard of Freedom House. Oh boy. Okay. Okay, so that's good actually, because if you don't know it, that means that you will not realize how completely overblown this metaphor is. So, Freedom House is an organization that measures freedom in countries. And it does this in a variety of ways, looking at press freedom and how democratic a country is, how much corruption there is, et cetera, et cetera, et cetera. And it draws up a map of the entire world and divides the world up into 3 categories. Not free, partly free, and free. So if you want to know the exact criteria, obviously, just visit their website. And every year they publish an index of countries. And then there's a little number that you get in terms of how free you are, and if that number is like above 60, you're free, and between 30 and 60, partly free, etc. The reason I thought of this as an apt metaphor for developer freedom is because there are different types, or there are different stages of sort of developer freedom in the sense of how much developers can do for themselves, how many decisions they can take for themselves. So in that sense, developers can be not free, partly free, and free. And I'm going to tell you about how developers at Bol.com went from not free to free. But then the other reason the metaphor is pretty apt is because freedom for developers as well as for citizens of a particular country does not mean anarchy. If you're free, according to Freedom House and according to how I would judge developer freedom, you're not literally free to do whatever you like. It's not anarchy. There is a particular framework. For citizens, it's called democracy. For developers, it can be company guidelines, etc., etc. There is something that constrains you in what you do, but despite that, we still consider people to be free. We still consider the citizens of Holland to be free, despite the fact that you're not free to go out and break windows at will, or burn cars or whatever. So in that sense, I think the analogy is pretty apt. And I'm going to use it in the presentation, and then afterwards you can tell me if it was completely stupid or not. Right, so going back to 4 years ago, we had a situation at Bol.com where we had a 4-week release cycle, and this was fairly rigid. So every 4 weeks, the sprint that was across the entire company, when the same sprint for the entire company or the entire IT department was wrapped up, and a new one was started. We had a big bang release, which also means the shop went offline. Raise your hand if you realize that in 2014, 4 short years ago, Bol.com, the biggest online retailer in Holland and Belgium, took their shop offline for a software release. 3 people. So the rest of you didn't notice because we did it at like 5 o'clock in the morning when nobody was awake. And the reason we can do that, obviously, is because we're really, really, really concentrated on the Dutch and Flemish market. And the Dutch and Flemish market is asleep at that time. But think about how mind-blowing that is. And it was for me when I joined the company, that the software release process is such that we just literally turn everything off and on again. Incredible. We don't do that anymore, by the way, thankfully. We had Scrum, like I said, about 200 user stories per cycle. Which went to production, and it was a question of deploying these 200 user stories to production and then kind of putting our fingers in our ears and hoping that everything worked. And sometimes it didn't, and the guys that would release the web shop at like 5 o'clock in the morning, sometimes at 8:30, would have to conclude that, okay, this downtime had cost us enough revenue, and we had to roll back to the previous version and figure out just which one of these 200 user stories had a problem that was delaying the release or preventing us from releasing successfully. The software was hosted at Schuberg Philis, so we didn't own our own data center or our own infrastructure. Everything was run by Schuberg Philis. They did everything for us, and the stack was Jenkins would build the software, a tool called Deploy It, which is now known as XL Deploy, would actually deploy it to the infrastructure at Schuberg. And the software was essentially thrown over the wall from the developers. After the development cycle had completed, it went to acceptance, and then it was sort of given to operations to run, and they would run your software. Crucially for my team, the team that I'm on, the tools team, every team did have their own admin rights to their Jenkins jobs. And I'll explain why that's important in a moment. So here we come to my metaphor that I'm liking more, to be honest. So, freedom index. I would say not free. There's a huge temptation to draw all kinds of analogies with countries that are considered not free, but I don't want to offend anyone, so I'm not going to do that. Developers couldn't do their own releases at the time of their choosing. It was all down to operations, essentially, that defined this or it was down to the company itself, which defined this 4-week release cycle. If you wanted to do a release halfway through, then you were basically out of luck, unless there was a huge bug in your software, and then you could do it, but not by choice. Releases had to be coordinated with Schuberg Philis, so they were kind of in on the whole process, and they had to be included. even to the point where some property changes had to kind of go through them before you could actually do them. The stack on which the apps ran was incredibly tightly locked down. So the developers produced a jar or a WAR file, and gave that to operations, and they would run it on a Tomcat platform, which from bare metal up until Tomcat was completely defined for you. There was nothing you could do about that. Developers could do all kinds of things on test, but they could do almost nothing on production. So there were endless requests for people to SSH into production boxes, which were always denied because, well, the developer might break something. And so there were essentially two levels of gatekeeping. There was operations on the one hand, and then after operations, there was Schubert Phyllis. There were two levels of sort of indirection before you actually could deploy something on production. So not free is my verdict for this situation. 2014 bull.com. They could configure their own Jenkins jobs, though. That was like the one thing they did have complete freedom in, and obviously they could do whatever they wanted in their own code, obviously, and could choose their own frameworks and stuff, but still not free. Right. So then we move on to the current pipeline, the one we have today as we speak. This situation of having a partner that managed their infrastructure for us, having teams that were completely reliant on the 4-week sprint cycle. As we grew and grew and grew, and when I joined the company, we had maybe 20 Scrum teams, 18 perhaps, and now we have, like I said, 55 and growing. As we got more Scrum teams, it became apparent that this was very hard to maintain, because the more you grow, the more applications you develop, and the more stuff goes into that 4-week release cycle, the more chances you have of there being some sort of bug that you haven't worked out in acceptance, and the more it just slows everything down. Because if you roll back something for 13 teams, that's 13 teams worth of work that you roll back. If you do it for 50 teams, let's say, then there's a huge swath of features that you can't bring to production because of one single thing that's wrong with the entire release. So this wasn't a scalable model, so to speak. So we introduced a program. Speaking of claims that are completely overblown, like my metaphor, introduced a program called Man on the Moon. The idea behind the name is that we had to make a really big effort, like the effort to put a man on the moon, to make all the teams basically autonomous. And by autonomous, I mean they could do their own releases at their own pace, and to break free of this whole 4-week Scrum cycle that was basically dictating the development speed of the entire company. So, the current stack. How did we give developers more or less more freedom, or I should say, how did we give developers more freedom than they had before? We have build, which is done by Jenkins, as before. Then we have artifacts, which are stored in a repository manager called Artifactory. We have a tool called rundeck, which is essentially a distributed script runner, which has a quite nice web interface that people can log into and kick off their own jobs. That rundeck, what that does is it takes the artifact from Artifactory. So the WAR file, in this case, takes it from Artifactory for a Java app, for instance, builds an RPM out of it, and then kicks off a Puppet run. Puppet configuration management software will then actually deploy that RPM to a virtual machine running on VMware. Now, it's important to note that this entire cycle, so the build cycle is just kicked off by commits or by people actually clicking around in the Jenkins user interface. The deploy cycle, so deploying stuff via rundeck, is done either automatically for the test environment or at the request of the teams, which they can actually go in and click the button themselves for production. So they're now free to deploy themselves. So the key aspects. Like I said before, teams had admin rights over their own Jenkins jobs, which in theory sounds great, but in practice was kind of a nightmare for us, because as there were more and more teams, there were more and more different configurations for Jenkins. And as my team that actually administers Jenkins soon found, people love to configure stuff themselves, but if it goes wrong, they still come to us to fix it. So in order to create kind of a baseline that we knew would work and to kind of constrain the options that people had in configuring Jenkins, so they wouldn't do crazy things like use experimental builds of the JDK or something along those lines. We created a system called TuxP, which is essentially a JSON configuration file that gets translated to Jenkins jobs. And the translation is done by us, by a piece of software we wrote, and that allows us to very strictly constrain the amount of variation there is in Jenkins jobs. Obviously, people can still do their own Maven commands and do whatever they want inside the software, but we constrain, for example, the different versions of the JDK you can use. We constrain how you use particular plugins in Jenkins. And all of this is to maintain the stability of the Jenkins platform, which is serving all these teams running thousands of builds per day to make sure that it doesn't fall over, A, and B, that we don't spend all of our time as a relatively small team chasing all kinds of weird configuration errors because people have done crazy things in the Jenkins configuration. So no more job admin rights for teams, which was necessary to keep the Jenkins installation scalable, essentially. Teams can now deploy to Pro at will. We have test environments and UC environments. Like I said before, UC is deemed to be production-like. It has the same kind of hardware setup. So if you run tests there, they're supposed to be more or less representative of how things would run on Pro. We had a change management process when we first started out with this whole Man on the Moon initiative. Oh, and I should say something that's not listed here because it was in a slide that I deleted. We moved from Schubert Phyllis to our own data center. It's also pretty important. Data center is run by our own operations people. So we took out that layer of dependency as well. When we started with our own data center, we had a change management process. It pretty quickly became apparent that having a change manager who has no idea what the hell he's talking about, make decisions about your software was really stupid. So we got rid of him. Well, the role, not the person. Raise your hand if you, sorry. Sorry. I was going to say, raise your hand if you're working in an organization, if so used to giving talks to groups of consultants that I forget that you're all basically working for the Rabobank, right? Yeah. So do you have a change manager? Oh, but wait, so in the Rabobank, you have these different units that all do like completely different things, right? Yeah. So do you have units that do and don't have a change manager? Or? Yeah? Okay, so raise your hand if your unit has a change manager. Right. Raise your hand if that change manager is basically useless to the process. Ooh, yes. Don't worry, they're filming me, not you, so they can't hold it against you. Right, so that's kind of the... Okay, I'm going to go on a small tangent, because change managers are kind of emblematic of this thing we have in software development where we think, well, maybe not developers, but people that have to manage software development think, if we build in enough safeguards, then our software will get better. So a change manager is that kind of a safeguard. A test environment is that kind of a safeguard. An acceptance environment is that kind of safeguard. If we build in enough safeguards, our software will get better, our releases will get more stable. And the truth is, that doesn't happen. Because developers, so before I say this, I'm a developer. Developers are lazy. Yeah, developers are really, really lazy, and that's great. How many of you here know who Larry Wall is? Raise your hand. So, Larry Wall created a programming language called Perl. Raise your hand if you know Perl. Yes, thank you. Right. So, Larry Wall sort of enumerated the essential qualities of a programmer, and one of them is laziness. You want programmers to be lazy. Why? Because they then take shortcuts and don't do useless work that doesn't need to be done. But that same laziness means that, for instance, if you have an acceptance environment, programmers will think, you know, I just coded up this really awesome feature and I didn't really have time to unit test or anything like that, but you know what? We'll take care of the bugs in acceptance. That mindset has cost Bull.com countless hours of debugging at a point where the software should have been ready to move to production. Change management processes, change managers, all those kinds of things that are supposed to build in safeguards, the only thing that they end up doing is slowing down the process without actually achieving the result of making it more stable. It's almost always the case. if you take out all of this stuff, if you let teams decide when to deploy without having them consult anyone, then the software almost always becomes more stable instead of less. If you give teams more responsibility, the outcome is better than if you give them less. Okay, so back to my story. That was my rant. Okay, SRT gatekeeper was still the gatekeeper of deploy functionality and new services. So the SRTs are what we call IT ops, essentially. They still control whether or not you can start a new service, whether or not you can deploy your software in a certain way. That's still sort of under their control. So, another slight tangent. This one planned though. Mayfly. Mayfly is a continuous delivery platform that we created inside of Bol.com because we apart from the fact that teams needed to be more autonomous, we also saw the following problem. So you have these environments, and you have all these teams that are working to deploy stuff to pro, but they have to go through tests and acceptance first. And we had everybody at Bol.com working on the same centralized test environment. So what happens when everybody's working on the same centralized test environment? Jenkins is building your stuff, is deploying it all the time. So you commit and it gets deployed. And then somewhere along the way in some user story, there's a bug that gets introduced. And if you're unlucky, that bug is serious enough to, in our case, take down the web shop, which means that basically all of Bol IT has to stop working because they can't test on the web shop. And testing on the web shop is sort of what we do. So you introduce a bug, test goes down, the web shop on test, or some service that's really important for the web shop, in our case, or in your case, think of whatever system is really important that could go down if someone screws it up. And then the entire IT department grinds to a halt because test is down. And then the other teams get upset, and the team that broke it gets really nervous because they have to fix it really quickly. If you're lucky and they're conscientious developers, if you're not lucky, then they don't give a shit and they just leave it broken for half a day until some manager comes to hurry them along. So obviously this is not, you can see how already with 4 teams this is kind of a problem. If you have 20 teams, 25 teams, let alone 50 teams, this is like a huge issue, right? So the idea behind Mayfly, as we first thought about, or as we first envisioned it in 2014, was the following. You have a development team. They're working on a user story. That user story has its own Jenkins, which deploys to an environment that is specifically created for that user story. So not a shared environment, but environment per user story. And from there, you deploy to production. You can do that in parallel for multiple different stories, and all the other teams can do the same thing. You've now broken the dependency on the centralized test environment that can cause so many problems when it goes down. Because now, if there's a problem in one of the stories or one of the teams, then one of the environments has an issue, but all the other teams can just keep working because their environments are still up and running. That's the idea behind Mayfly. We based it on user stories because, like I said, we're big into Scrum, and it was really easy to sort of link the entire creation of environments and stuff to Jira on a user story level. So per user story, you get a feature branch in the source control, currently Git via stash. Not entirely sure why I included that detail, but there you go. Continuous integration jobs in Jenkins. Isolated production-like a runtime environment using Docker. So we really sort of bet big on Docker and used that to isolate everything from everything else. We had an automated definition of done check. So if you're familiar with Scrum, the definition of done is like, when is your story done? Well, you can sort of, we introduced a mechanism whereby you can codify as much of that as possible. So you can introduce checks that say, well, did the unit tests all pass? Does my application actually run when I deploy it in my test in my isolated environment? Is it a Friday, for instance? Teams can create their own rules. Logs and metrics, like we're used to in the test, acceptance, and production environments. and optional user story specific databases, so Oracle or PostgreSQL, Mongo, whatever, deployed along with your isolated environment, so you can use that to test your functionality. In 2014, we started developing that. As of today, 30% of all commits within bull.com are done via Mayfly. And here I get to the theme of this, what is it, a conference? Call it a conference today? Conference, gathering, event? I don't know. Theme of this event. How did we fail? So 30% of commits, like I said, done via Mayfly. And I should note that the continuous integration job, the Jenkins job, and the way you deploy stuff is all fully customizable by the developer. So lots of freedom within this process. Right. You would think that given the fact that developers have a lot more freedom within the Mayfly platform than they do on the sort of traditional platform, that everybody would immediately move to Mayfly and start using that. However, here we are 4 years later, 30% of all commits done via Mayfly, 70% of them not done via Mayfly. This is pretty much a failure. If you have something that is, in theory, so enticing, but not everybody is using it, you've pretty much failed. And why is that? Well, we made all of this happen, but because we were so focused on giving the developers what they wanted, we neglected to actually make sure that what they produce, what came out of this Mayfly platform, went to production, as in my original diagram, and then it went to test instead, and we ended up just making the test platform more stable, which is also nice, I guess, but the whole point was to get rid of the test platform altogether. So we failed in that sense in getting as much adoption as we wanted, because we couldn't get essentially the operations side of the company up to speed quickly enough with all the stuff that we were doing. We failed in convincing them that this was sort of the way forward, and that they had to sort of re-architect all of their systems to use Docker and all this other stuff that we were using on the development end, so that the Mayfly platform could actually deploy to production instead of deploy to test. So even though there's a whole bunch of positive spin-offs that came off of this initiative, like people got acquainted with Docker, et cetera, I think it's kind of difficult for me to say, to be honest, because I was one of the people that created Mayfly, and then to stand up here and tell the Rabobank that it was actually a failure is... But I have to do it, I think. I owe it to you guys, I guess, to admit that it was a failure. Whoops. That's inconvenient. Sorry about that. Not sure which button I hit. Anyway, 30% adoption after 4 years of something that is sort of demonstrably better than the alternative, and people fail to adopt people still stick with the alternative, you've pretty much failed. Right, so after this moment, we'll move on to more positive things. Right, so yeah, thanks. So we failed, and what did we learn from that? Well, we moved ahead of the rest of the company at a very rapid pace, and took along some teams that were really into this way of developing software, using Docker, doing all kinds of sort of modern things. We moved ahead of the company at such a speed that at one point we were actually running our own Mesos clusters. Mesos is a distributed computing framework. We were literally running it on computers that were sitting under our desks, when we had an infrastructure team that could have done that for us, except they didn't have the time at the time, but we didn't want to wait. So we ran ahead of everybody else, and we were kind of waving to everyone to join us, and then 30% have, and the other 70% said, well, I don't know. So the lesson there is to, even though you're really excited about technology and you want to get started as quickly as possible, sometimes it's more important to build that consensus, spend a little bit more time getting people to come along with you, and kind of trading momentum for consensus in a sense. That's the sort of lesson that we drew from all of this. Having said that, back to our freedom index. So developers control their releases in the current situation, right? Developers don't control their continuous integration because of the whole framework that we built. Like I said, they can do a lot of stuff, but they still have to go through the framework that we built before it lands in Jenkins. They don't control their delivery because that's still controlled by operations. And Mayfly offers a lot of freedom. It's, if you're working with Mayfly, it's awesome, but it only gets you the tests, and then from there you're still in the same pipeline as everybody else. So I'm going to say partially free. I had a really hard time finding a good image for partially free, so I found this one. So you're outside, right? You can see like the world outside the house, and you can see that's pretty awesome, but you can't really go. You're still constrained. So then, during the course of last year, we decided that we really weren't in the business of building and maintaining data centers, so that we should probably look at going to the public cloud, like most people in the IT industry. It was kind of for a lot of people in the company, the sort of final moment at which we said, okay, we should really take a look at this was when we visited Nationale Nederlanden. And they have this whole initiative where they're doing stuff on Amazon, and we thought, well, if this heavily regulated insurer can do it, then there's no reason that we can't. So, but the move to the cloud for my team was a really good opportunity to kind of rethink the whole CI/CD pipeline and see if we could really sort of set developers free. Finally, sort of take what we learned from the abortive Mayfly experiment and work that into something that the whole company could use and that also operations could get behind. So the challenge, build a container-centric, because, well, everything is container-centric these days, cloud-native CI/CD pipeline that is easy to use and get started with, so that's really important. It has to be like dead simple to get started with. Makes it easy to deploy small changes, really small changes. It's fully customizable by developers and can scale to thousands of deploys per day. So we really want people to be deploying like more or less every commit, ideally, because if you do that, if you deploy really small steps, then if it goes wrong, you know exactly where it went wrong. Whereas if you deploy really large chunks of code and something goes wrong, you have to go digging through the let's say 50 changes you made to see exactly where the bug is. Whereas if you're deploying 2 or 3 changes at a time, it becomes really clear really easily. Also, if you have to roll back from 2 or 3 changes, it's not as big of a deal as if you have to roll back from a huge release that includes like 2 weeks of code, for instance. So what about the current stack that I told you about before? So much as I love to kind of do new stuff, people force me to think about whether or not what we have is good enough, because, well, if it is, then we should just use that. Sorry, my timer reset. Oh, 5 minutes, exactly. Okay, great, thanks. So Jenkins did the builds. So Jenkins is kind of a maintenance nightmare for us. Anybody here familiar with Jenkins, running Jenkins? So not that many, but all right, take it from me, that's a maintenance nightmare. We wanted to get rid of it. Artifactory can store Docker images, which is kind of our new deployment model, but it's kind of expensive for that purpose. So Rundeck is not actually a deployment tool. It's just a script runner where you have to build all the deployment strategies yourself. It's kind of a pain, so we wanted to move to a tool that does actual deployments and has that as a first-class citizen, so to speak. And Puppet, installing software. So it was installing the software in place, and what we really want to have is immutable infrastructure. When you deploy something new, you don't replace the old, you keep the old around, you put the new next to it, tell the load balancer to send all the traffic to the new version, and then get rid of the old one. So don't update in place. So the current stack would work, but we'd rather move to something that's, shall we say, more cloud native, if you'll forgive the cliche. So what we ended up settling on is GitLab CI. That has a lot more developer control over your CI pipelines, a lot less bells and whistles, which makes it a lot more maintainable for us. Google Container Registry, as we're moving to the cloud, to the Google Cloud in our case, we just sort of outsourced that whole problem to Google. Don't have to worry about it. We use a tool called Spinnaker, which is a purpose-built deploy tool built by Netflix and also by Google that does cloud deployments in a really nice way. I urge you to take a look at that if you're interested in those kinds of things. And we run everything on top of Kubernetes, which uses Docker containers, which kind of forces you to use the immutable infrastructure paradigm. And this is also really important. Opt-out is an option, right? So we have convention over configuration. So we do a lot of stuff for you. From the outset, we create pipelines for you that have best practices embedded in them. We try to convince you to use our stuff. We don't force you to use our stuff. We're building a product that needs to actually appeal to people. Iterate on a vision, don't crowdsource the design. But the important thing is, if people don't want to use the stuff we build as a team, then that should be their choice. They can do whatever they want for themselves on the cloud platform. They don't have to use our tools. So, back to my freedom index. I would say that the new stack, in the new situation, developers are actually free. Why? Because they have full control over CI. They can do whatever they want inside of GitLab. They have full control over CD. They can configure whatever pipeline, whatever deployment strategies they want inside of Spinnaker, what I was talking about, the tool I was talking about. They have full control over the stack because what they're deploying is Docker containers, and they are completely in control of what is inside that Docker container. Obviously, there are sort of pre-built Docker containers that we as a team provide so that people can get started quickly. But if you want to create your own custom Docker container to do whatever you want inside, that's possible. So from the kernel up, if you know how Docker works, the kernel is still controlled by the infrastructure team. But anyway, and the constraints that do exist are handled transparently as much as possible. So for instance, in the Kubernetes cluster, we deploy applications to certain nodes and not to certain other nodes. That's handled completely transparently for the developer. That's handled behind the scenes by tooling that we've built or that's available natively in Kubernetes, so people don't have to worry about that. The constraints are there. Just back to my metaphor, just like in a democracy, there are constraints, but they are handled as transparently as possible. And opt-out is an option, like I said. But if you choose to opt out, if you choose not to use all the tools we provide, then you have a lot of responsibility to sort of satisfy the demands that we make of the platform. So you should have logging, you should have metrics, you should have alerting, et cetera, et cetera. If you don't want to use the frameworks that we provide for that, that's fine. You have to build your own stuff for that. And if that makes sense in that particular team's use case, then that's fine. So totally free. Well, yeah. In terms of my index, free. That's it. Thank you very much. So, any questions?
It works. Thanks for the talk.
Yeah.
I was wondering, you mentioned the developers having full control over the environment and the code up until test.
Yeah.
In the new setup in Google Cloud, do they have also it up all the way to production? Is it still separated, or is it just one environment?
Right. So ideally, it would be one environment where there is no. So what I mean by that is one environment in the sense that you're running your production, your test workloads on the same infrastructure. It turns out that that's not really that good of an idea when you're using Docker, because the isolation is not that strong that that's really something that you should do. You still have the problem with like noisy neighbors, and in terms of containers or containers that can be exploited, that sort of thing. So you kind of want to keep stuff separate still. But so we don't have one environment that runs everything. We still have a staging environment and a production environment, but those are the only two that we have left out of the 4 that we started with when I joined the company. And in terms of the control they have over production, like I said, if they want to run, so most of our services run on top of Tomcat servlet engine. If they want to run Jetty instead, they can, because they can just use a different Docker image that has Jetty instead of Tomcat. So they don't have control over the production servers. They can't log into an actual Kubernetes node and do stuff there, but they don't have to, because there's no point. They can just change whatever is running in their Docker image and control it that way.
All right. Thanks. Who wants it?
Hello.
Yes.
Yeah, you showed that the teams were deploying with their own Jenkins to their own environments.
Yeah.
And from there to test for production.
Mhm.
Where is the integration testing happening?
In the isolated environments.
In the isolated environments.
Yeah.
But each team is deploying their own.
Yeah.
So they all come together.
Yeah. So that's the idea of the isolated environments is that you kind of simulate production in them, and you don't do that by actually setting up the entire production environment in every environment in every isolated environment, because that would be really expensive, and because we have 200 plus applications and Oracle licensing issues, but that's another matter. So you have to kind of rely on the APIs of the services that you consume and test it with stubbing and mocking, and that's kind of the philosophy that we try to spread inside the company. Not only because that makes it a lot faster if you're testing against APIs which are mocked, obviously your tests become a lot faster, but also because we have an integration testing environment in acceptance, which also is used for performance testing. But if you think about it, if you do integration testing, you have to know what you're testing, right? There's no point in integration testing if you're testing, let's say, 4 pieces of software that work together, but they're constantly changing. But if you move to a continuous deployment type of model where every team can choose when to deploy, acceptance is always in a state of flux. So you don't know if you start your integration test at time slot A and you reach time slot B and your test is done, but halfway through, half of the environment has changed versions, then what have you just tested? What's the point, right? So then the sort of logical conclusion of that is that the only real integration and testing environment that's left is production, which is great because it has all kinds of production-like features and production-like data, right? So it's actually a really good integration testing environment. And so if you think about it logically, that is the only integration testing environment real integration testing environment you have left, because everything else is just you don't know what you're testing essentially, because it's all the versions are in flux all the time. You could choose to, as we did in the past, say, well, we're going to spend like a week doing integration tests with a fixed set of versions, but that means that everybody has to wait around for a week before they can deploy new stuff, and that's just if you have like 60 teams, that just costs way too much money. And again, as I said before, it's one of these measures that you take because you want to build in control and stability, but in the end it just ends up costing you in terms of speed, and you don't get the stability you're after anyway. So,
okay, thanks.
Thank you. Can you tell about using of test automation?
I'm sorry?
Test automation?
Yeah, so test automation, back when the sort of centralized testing environment was all we had a suite of automated tests that ran twice a day, once in the evening and once in the afternoon, or once at noon, I should say, that ran on the centralized test environment. And a lot of the services that are behind our web shop, so a lot of services that the web shop depends on, were actually tested through the web shop. So when I first joined the company, I worked on a return service, and most of the tests we wrote for that service or the testers wrote for that service, I should say, were clicking through the UI of the web shop, doing a return that way, and then making sure that the end result was what we expected. So we had this centralized test environment with centralized automated tests that ran twice a day, completely divorced from any release of the software underneath or anything like that, just run twice a day. When we introduced Mayfly, we really encouraged people to do all the automated testing inside their builds rather than on the centralized testing environment for 2 reasons. One, because it's a lot more predictable. We had test runs almost every day that had a whole bunch of failed tests, and the sort of standard assumption was, well, there must be something wrong with the environment. someone has deployed a bad version of some service which causes my test to fail. So it must not be an actual problem in my software. It must be a problem with the test or the environment. And in order to sort of get rid of those kinds of suspicions, which make people really lazy, you should do as much as possible in the build where you completely control what's going on because you're starting it all yourself. And also, the feedback loop is a lot shorter. You get a lot more, the build times, so as you said, the tests that you run in the build are usually kept quite short because you don't want to wait around for an hour and a half for your build. So people have been doing that more and more and more. We still have the centralized test environment, and we still have this this bunch of centralized tests that run on it twice a day, but the amount is getting smaller and smaller and smaller all the time. And yeah, so now with the move to the cloud, we're essentially going to say, well, we have the staging environment, but it's not going to have the same status as a centralized test environment that we had in our data center. And there's been a huge effort among the test community within the company to really get people to test inside their builds and inside their isolated environments to get rid of the shared automated testing. So, does that answer the question?
Yes, actually, do maybe just specify. So within a team, they test only their own functionalities, what they have built. So they don't do chain tests there.
Right. So before they did, if you work on a service that's part of the web shop and you test it through the web shop, you're not just testing your service, you're also testing the web shop. That's not good because you're testing all kinds of things that you have no business testing. People that develop the web shop should be testing the web shop. So yeah, we have this notion of every service belongs to a particular Scrum team, and they are responsible for writing the tests for that service, and they are not necessarily responsible for writing the tests that go through the entire chain. Yeah.
Thank you. That's easy.
Oh, sorry.
At the start, you mentioned about the downtime for deployments.
Yeah.
Do you do something special for zero downtime, like blue-green deployment model, or?
By the way, please don't tell anybody outside this room that we had downtime for deployments because it's like hugely embarrassing. But anyway, so we don't. We do rolling releases, and we do have. Sometimes we still do have downtime because there are certain. The way we have our databases set up is such that sometimes we just, to do a deploy of new PL SQL code or whatever, the easiest way to do it is to have downtime. So, and we haven't put in the effort to actually make it so that we can do those without downtime as well. There's a whole bunch of teams that have started using frameworks like Flyway or MyBaddest Migrations that allow you to do database updates from inside the software. And so we use those techniques, but we've mostly focused on moving as much of the functionality as possible out of the database into the services. And then you can do a rolling update of the services and not touch the data model too much. And that way you can get zero downtime deployments.
Okay, thanks.
Oops. Wasn't officially part of my presentation. Just
Any more questions? I'm not going to
Yeah.
Okay. Let's keep it easy. Thank you very much.
Yeah. Mm-hmm.
Oh, thank you. So we're near our almost most important part, except for the content, of course. First of all, we're nearing the end. As we said, there's drinks after, as you've known, probably. We have a winner, Roel Veldhuizen. Where is he? Yeah. I will take the list. We had about 30 people doing the test. Slight exaggerations, but 169 points. So congratulations. Please people bow for him. Yeah. Yeah. And if all goes well, we also do have a prize for you. Kijk. Which is, of course, a book about the subject. Yeah. It's a novella. Geniet van. Yeah. So, our winner. The Pluralsight's services are for at least tomorrow still available for everyone. So this is a subscription that's free for us thanks to Pluralsight. They sponsored it. If you really want an account, there's only a few that last longer. We have still some available through tools.rabobank.nl, but we're almost through. So if you want them, push the button and you get one. Next event, it will be in May or June. And since this subject was about failing and learning, our speakers would like to learn as well. So if you have any feedback, you can use the Scat app to give a response to your things you saw could improve or you valued very much. Please use it because last time we valued it a lot. Yeah. For now, we have the thank yous for everybody who participated. So please, everybody who did a presentation or a workshop or was on the stage, come forward because we have more books. And will the organizing committee join them? Throw more. Ja, oh. Ja, doe jij dat gedeelte? Ja. So if you want to be on the podium during the next session and get other presents because we hate repeating ourselves, you could be here as well because you have lessons we can use for each other. You can share. Don't be shy. There's always something that we can learn from you. Thank you all. Yeah. You have it? No, there's still a few. Then the sticky note is niet onder de stoel, hè? No. So if you go out, there's Sophie standing over there. She is carrying a lot of sticky notes, or there are more people that I see. We ask you to write one item of feedback on a sticky note. It does take you about 10 seconds. Write one item each when you get out, so we can use it to improve our next session. Yeah, please do that. And then thank you all for coming, and let's have a drink. Yeah.